Hello friends, hope you are having a fantastic day today. So in this course, we are going to learn everything there is to know about heap and priority queue. We will understand that what is heap, what is min heap and max heap, what is priority queue, how to implement heap, what are the benefits and limitations, time and space complexity, operations you can perform, and the most important part, under what type of scenarios should you consider using heap or priority queue to solve the problem that is currently at hand. After that, we are going to learn 11 most popular, most asked and most like heap or priority queue related questions. These questions are extremely popular. They have been asked at tons of different companies multiple times, and my expectation is that by the end of this course, you should become a complete pro in all sorts of heap and priority queue questions. Now, let me give you a quick introduction about myself. My name is Parth Vyas, and I have been in the IT industry for close to 10 years now. I have worked at companies like Royal Bank of Canada, Microsoft, Nokia, and currently I'm working as a solutions architect in Cineplex. So I was born and raised in India, and since last 10 years I've been living in Canada. I have bachelor's and master's in computer science. On top of it, last year I became dad of two beautiful twin daughters, and that's why you see all of these teddy bears playing around me. So now, without any delay, let's get started with the course. So heap is nothing but a very special type of binary tree. The thing is, heap contains two very special properties that differs it compared to rest of the other binary trees, and also it is slightly different than binary search tree as well. So let's understand that what are the two unique properties or characteristics that heap possesses. Number one characteristic is that heap can be of two types. It can be either a min heap or a max heap, and for both the property is very similar. The only difference is if the heap type is a min heap, that means it contains a very special relationship between a parent and its child node. The relationship is that the parent node is always going to be less than the child node. That's it. There is no particular pecking order that left child is needs to be smaller than the right child or whatnot. Same way for the max heap, it's the reverse order, that at any given moment the parent is always going to be greater than the child, and once that property is followed, we can conclude that this is a max heap. Let's say that suppose we are currently given these nodes that follow the property of min heap. So logically, the root node always has to be smaller than its subsequent child node. If this is the case, we can clearly see that in this case it follows the property of a min heap, where at root level the value is always going to be smaller than all of its subsequent child. So over here we can see that this 0 is the smallest element, and if we see the child, it is the value 2 and value 3. Once again, even at the subtree level, we can see that this 2 is actually smaller than its child 6 and 7. Same way, this 3 is actually smaller than 4 and 5. Now, at a first glance, this looks very similar to a binary search tree, where in the binary search tree, we have a condition that left node or left child is always going to be smaller than or equal to the right root node, and that is always going to be smaller than the right child. So in this case, though it looks very similar, this property is not always maintained in the heap, and that's where binary search tree and heap differ with each other, where we can see that in this case we have value number 4 present over here as part of the right child, which in theory, if this was to be a binary search tree, 4 has to be located somewhere over here, because the 6 and 7 are actually greater than 4, which means we do have some property inside the left subtree that is actually greater than some property in the right subtree, and this disqualifies this particular entire tree from being a binary search tree. But even though this is not a binary search tree, this is still a heap. So now let's go back to our discussion. I mentioned that heap needs to follow two special properties, but I have only explained just one property, and that is that currently I have only explained you the property of the difference between parent and child. The second property that heap contains is that heap tend to be a balanced heap or a balanced tree. Now what does a balanced tree means is that at every single layer it tries to balance out the nodes, and the only place where heap may not be balanced is in the last layer. So let's say that in this particular heap, if we have to consider this, this would still be a valid heap because all the values are placed in proper balancing order, and in the leaf node or in the very last node we have all the values that have been filled from left to right. And if this is the case, we can identify this as a proper heap. Now let's try to play around with some examples with these two properties, and we will try to guess that whether they are heap or not. Okay, so let's try to take this first example and we will try to understand that whether this is heap or not. So as we can see in this case, we are actually following the property of a max heap. Why this one is a max heap? Because notice that at every single root layer the parent is always going to be greater than its subsequent child values. So this is the property of a max heap. So at this layer max heap property is followed, at this layer once again max heap property is followed, and once again, so we can see that each of the subtree follows one property of the max heap, which means this is correct. Next thing, we will have to check that whether this is a balanced tree or not. So currently we can see that this particular root node 3 contains two child, but that is because we only have these many elements, so this is the only possibility. So this is still a valid heap, and this one is actually a max heap that is currently valid. Now let's try to take another example for this one. Now this one seems like a min heap. The thing is, this one is smallest value, and we can see that its subsequent children are greater than smallest value. So far this is correct in terms of min heap. If we see the structure of this particular binary tree, this also looks a balanced binary tree, so there is no issue with this. But when we do and identify the differences amongst these two elements, we can see that if this was supposed to be a min heap, then this value, this child, this parent has to be smaller than its subsequent child, which is not the case over here. So we can say that this is not a proper example of a heap, so this is not a valid heap. Same way, if we look at this example, once again this looks like a max heap. We can see that it is following all the property of child being smaller than its parents appropriately, no issues with this one. But this is also not a valid tree because, and remember I told you that all the child has to be filled from left to right. In this case we had one space over here and we have one space over here that has not been filled as part of the child, and we have this child being located over here, which means this is not a balanced tree. So this is also not a valid heap. And once again, this is another example. So in this case we can see that once again property of max heap is being followed, but the issue is that this is also not a balanced tree because of this particular element. If this was something like this, then this would have been a valid binary tree, but or a valid heap, but that is not the case. The answer is quite simple. I mentioned that heap has two types. First one is a min heap and second one is a max heap, and both allow us to gain a very specific property. With the min heap, we can also always find the smallest element inside the entire binary tree at the root location, because remember, what is the definition of min heap? It's quite straightforward, that every single parent has to be smaller than all of its child. So in this case, because this is the parents, or this is like the root tree, also it is parent to every single child, which means this has to be the smallest element inside the entire binary tree. So this is the most beneficial item for a min heap. Same way with the max heap, we repeat the same thing in the reverse, that parent has to be greater than all of its subsequent child. And if this property is being followed, then no matter if we had like 500 elements inside our heap, at every given location we would have maintained the property of it being a min heap or max heap, and we can always find the root node to be the maximum element amongst all of these elements in this case. So this is the primary benefit of maintaining a heap, that at any given moment we can identify that what is the smallest element or what is the largest element inside the entire heap. Now question comes, binary search tree does the same thing. There is a slight difference, and that slight difference is that I mentioned that in the binary search we are maintaining the property of left child being less than or equal to root node, and root node being less than or equal to right child, which is not what we are maintaining inside the heap. In the heap we only care about is that at any given moment the relationship has to be between parent and child. And there is another reason that why are we maintaining this type of hierarchical structure, Because, or why are we maintaining this type of balanced binary tree structure? Because we don't want to be in a situation where we have all the nodes just like this, or something very inefficient, something like this type of structure, because this takes a lot of time to find and figure out elements, that what are the smallest or what are the largest. If we had a balanced tree, basically we will have to do less number of iterations to go down below inside our heap, and that is another one of the benefit of heap compared to binary search. And the reason I'm putting so much emphasis on giving you the differences between binary search tree and heap and other binary trees is because this is the core concept, that why are we actually building heap. Understanding this would always give you a click in your brain whenever you encounter a heap related question, or whenever you encounter a real life scenario where you have to keep track of the person or the number of instances where you need to find out the smallest value quickly or the largest value quickly. So now let's try to deviate away and try to understand one more important principle. Queue is a very simple data structure where we simply follow the normal principle of first in first out, where let's say that we currently have elements come in from this way, and then we have values coming in 0 1 2 3 4 in this fashion. Then the values going out are also going to be in the same fashion, and we are going to have a valid legitimate queue. In real life we see many examples of queues being formed. Maybe we go to banks, or maybe we go to ATMs or places to fill up our gas. We follow the same principle. But the thing is, many times in reality we might have some situation where some nodes actually or some person actually needs to be treated little bit differently, little bit specially. That this is true in terms of real life scenarios like banks or places where you need to go for public gathering. Because imagine if someone is like disabled, or someone is pregnant, or someone, there is some elder fellow, then in that case we try to give them higher priority compared to rest of the people who are already currently placed or already currently waiting inside the line. Because let's say that there are four people in the line, suddenly a person comes in and that person may be physically handicapped. So you don't want to be that bad person to say that, hey buddy, you need to follow the line. You actually wants to be generous enough and try to give that person the priority to complete their task first. And this is what many times we have to do inside the computer systems as well, where we will have to implement some sort of data structure that typically does the work in normal, like typical queue fashion. But from time to time we may have some priority nodes that come in that needs higher priority or higher resources, and that needs to be tackled immediately. So some example could be, let's say that currently I have a system like Amazon, where in the Amazon I'm usually trying to process the orders that come in regular intervals at normal times. But imagine that I suddenly realize that someone is trying to purchase a value of $50,000, and that might be suspicious. So do I actually wants to put this order behind the queue and leave the customer and be like that customer already placed their order and now they are just waiting for their confirmation? No, I actually wants to process this order immediately, because this is a high priority item that I need to get rid of. So that's why this is going to have higher weightage and this would be processed first. This concept is also applied and desperately needed inside the world of computer science as well. Well, we already know, or we already have a queue-like data structure where we follow the principle of FIFO. But the thing is, this is where using heap comes into the picture to actually implement priority queue. Because remember, what does heap do? Heap at any given moment can say that this is currently the highest priority if we are judging the priority based on the minimum value of something, or this can be the highest priority if we are trying to judging something based on the maximum priority of something. In either case, if we have implemented the heap correctly, we can actually process priority queue in the simplest fashion, because at every single interval or every single moment we are going to be able to find out that what is the node that contains the highest priority, depending on whether the minimum property or maximum property we are trying to differentiate. And then we are going to be able to say that this is the node that you should be processing right now. Now coming back to my question, why would you assume that only minimum or maximum would be sufficient enough to determine the priority of any particular node? And that's where the normal concept comes in, where let's say that there are currently two people waiting right now, and you want to decide that amongst these two people, which person are you going to give your groceries. Okay, let's say that you are currently grocery shop owner. So if there are two people, what you are going to do, you are going to do some sort of comparison. You are going to say that which person is maybe willing to pay me more money, or which person is maybe like dying of hunger, and you want to help them. So there is always going to be the game of comparison you are going to be playing amongst any two available node or more than one nodes. So whenever the comparison comes in, one has to become the winner based on some property. So this is what heap allows you to find out. It says that okay, you tell me what property you want me to judge nodes based on, and depending on the property, whatever the value you set up, you can always find out that which node contains the highest priority. And if there is only one node left, then that one node is the highest priority because there is only one node. So this is how combination of heap and prior concept of priority queue can actually give birth to some of the most amazing and very fastly performing data structures and algorithm items that we can do. We all know the property of a heap. Number one property is that heap is always going to be balanced, and second property is that heap is going to have a parent child relationship. So if it is going to be a min heap, then parent is always going to be smaller than child. If it is a max heap, then parent is always going to be greater than heap or greater than its child. So let's try to understand this, and we will try to understand conceptually that how does implementation of heap works. So let's say currently I only have one node, and that is node number 5. Okay, and I'm trying to maintain a max heap. Now logically, the core concept of a heap is that you are always going to add values to the bottom place or to the last element. Then you are going to be checking that whether whichever property you are trying to maintain. So currently we are dealing with the max heap. You are trying to see that whether this property is followed or not. If this property is not followed because we added the value at the very end, we are actually going to do a shift up or bubble up operation with the parent. So wherever we see that this property is not being followed, we will swap the values of parent with its subsequent child. So let's say in this case, the value we are trying to enter is value number 7. Now we all know that 7 is greater than 5. So let's first add value number 7 over here. Now we notice that this max heap property, if that is being followed, no, it is not followed. So then we are simply going to do a swap operation, and we are going to have 7 located at the top, and then we are going to have 5 located over here. Now let's say that next element we are trying to enter is going to be value number 3. So we will simply add value number 3 over here. So currently after adding this 3, does any equation change? No, because 7 is still greater than its child 3. So that's good. Now let's say that now once again we want to add value number let's say 1. Okay, so if I add 1, 1 is going to come over here. Once again this is good. Now let's say I want to add value number 4. So once again value number 4 I can add without any issues. Now once again I want to add value number 6. So if I want to add value number 6 over here, what's gonna happen? Well, we are going to see a discrepancy between these two nodes. So we will have to do a swap operation or a heapify operation. If we do heapify operation in this case, then this node 3 is going to be replaced by node 6, and then this 6 is going to have node number 3. And notice, because of this heapify operation, we are actually never going to be able to maintain a binary search tree, because at any given moment we might have to swap with either left child or right child. So that's the difference between heap and a binary tree. Now let's say that in this case we want to add value number 9. So once again we added 9. 9 is definitely greater than 6. So we are going to do a switch operation. So if we do that, then our node value number 6 is going to end up over here, 9 is going to end up over here. But this is still not correct, because we still have a parent that is smaller than its subsequent child. So once again we are going to do a heapify operation for bubble up, and this is going to be 9 and this is going to be 7. And this is how the implementation of heap works, in order to maintain the property of this being maximum heap, or this, or maybe we can have same example for a min heap as well. And finding this property is going to be very crucial and very useful. Now let's imagine a scenario where we might have to kick one element out, because in the priority queue, once you process the node, there is no point of keeping that node as the highest priority. So let's say that in this case we decide that this 9 has been now processed. So once this 9 gets processed, we will have to do the heapify operation again. So in that case, the simple thing we are going to do is we are going to check that what are the subsequent child of this particular element, and whichever poses the greater value, that value needs to be switched up. So in this case 7 would be shifted up, but now the 7 is once again empty. So once again we are going to repeat the same process. We are going to find the value with the highest value, so in this case which is 6. So once again this 6 is also going to be shifted up, and we are going to have this node becoming empty. So remember, inside the heap, whenever we process a node, we always have to do shifting operation, but eventually the node from the bottom is always going to be removed. It is never going to be that node from the middle gets removed and then there is nothing and then there is an imbalance in the tree. No, it's always going to be a balanced tree, and we are going to maintain the heapify property very easily, very thoroughly, and very clearly. So here is a simple implementation for min heap class, and you can do the same implementation for the max heap. We just have to change the condition. So let's understand that how we are going to do it. We can see that we are actually going to use an array to represent a heap, which means in an array we will have to identify that for any particular given value, what are going to be the parent node and what are going to be its child node. So we will figure it out. First, this is a simple constructor to create a new instance of a min heap based on given capacity that we can maintain. Now we have some helper methods, that is this parent, left child, right child, and is a leaf or not. So this simply identifies that because we are using an array, we can define that based on any given index position, we should be able to identify that who is the parent of that particular index position, what is its left child, what are the right child, what is its right child, and whether that given node is the leaf node or not. Next, let's learn that how we can actually insert a new element inside into the heap. So for that, it's a pretty simple process. First, we check that if the given heap is full. If that is not the case, we are going to check that what are the current elements, and we are also going to increase the size of the existing heap. Then we are going to do the heapify operation, and we are going to do the swap operation. So the logic is quite simple, that because remember we are going to be adding the element inside the very last position of the heap, and after adding it to the last position of heap, we are going to check that for the current position where we are inside the heap compared to that with its parent node, if we follow the property of the current node being smaller than its parent node, if that is the case, then we would have to do the heapify and bubble up operation. So we are going to do the swap amongst elements, and then once again we are going to repeat the same process by marking the current node as the parent node, and keep on repeating until we reach to a place where this condition is no longer true. Same way, if we want to do the remove min operation, which it's quite straightforward, we simply have to remove the very first element that is currently present inside the heap, and then once again we will have to make sure that what is the current element or the main element inside the heap, that is that we are going to find the minimum value amongst the remaining child, and we are also going to reduce the size of the existing heap by removing the last element, and once again repetitively doing the heapify operation. So here is the condition of the heapify operation we already talked about, where we are going to check amongst the left child and right child for any given node to make sure that whether we need to do the heapify and are we following the property of min heap or max heap depending on whatever the values we are given. So this is that logic that we just saw inside the construct inside the inside the conceptual overview of the heap. And same way we have a very simple swap method, that is just to swap two elements. This is a pretty elementary method. So this completes all the items we need to implement our heap, and then we are going to have our main method where we are adding bunch of different entries inside the heap, which we can see. And as we know that since this is a min heap, we are trying to fetch the minimum value of this particular all the values that we have inserted. Now we can see that so far the minimum value is 3, and which is what we should be returning based on our heap operation. Let's try to run the code. and we can see that the value returned is min 3. So which means our class works fine. Okay, now we understand all the way on how implementation work, what is heap, what is priority queue, what is tree, what is binary tree, binary search tree, differences of each one of them. Now let's try to understand that what are the benefits, or under which type of scenarios should you start thinking about using heap. So number one benefit of heap is that at any given moment you can identify that what is the element which contains the highest priority, and you can work on that. So whenever you are dealing with any question related to priority, you always have to make sure that you are following, you can try to think that, hey, in this scenario, can I use a heap or can I use a priority queue to solve this problem? And more than likely you would be able to solve this one. Next thing is, you will also have to understand that at any given moment you are being told that what is the kth highest element or kth lowest element or something like this. So k, maybe some anything with kth. So and this k can be like third highest, fourth highest, like third lowest, third biggest, third largest, third smallest. Whenever you see any particular type of this type of condition, in that case that answer has to be solved using a min heap or max heap. Now the question is when to use min heap and when to use max heap. I'm going to give you a shortcut that is going to be very much helpful to you. Imagine that, let's say currently I have these 5 elements that are given to me, right? And they are just placed in random order and I don't know which is which. Currently these are the 5 values. Now the question is, I tell you that find me the third largest element. Okay, so which means the logic is, or not third, but let me give you the question for, let's say, second largest. Okay, this would make more sense. So if I want to find second largest element, so then because we are trying to find largest element as in biggest element, so the idea is that we, whenever you want to find big or find bigger element or larger element, try to build the min heap. Okay, do the reverse. Okay, and why we will do that I will also explain it to you. Do the reverse. So build a min heap, and of what size? It has to be of size 2. And now let's try to do our logic that I'm suggesting. So currently we have our min heap of size 2. Now the only thing we are going to do is, whenever we realize that there is a new value we need to bring in, and that new value is actually greater than the very first element we currently have, then we are going to pop one value out and we are going to push that value inside, and automatically heap will maintain. You will see what I mean right now. So let's say currently we have value number 5. Currently we are maintaining the min heap. So 5 is the smallest element we find. Next is value number 7. Okay, so once again we are trying to find the min heap. So once again 7 is going to be placed later. Okay, currently we had space inside the heap. Now let me also make some changes. Okay, this one is 8, let's say, and this one is value number 9. Okay, now we have value number 1 coming in. So should 1 come in? Currently heap is full, but the thing is this 1 is actually smaller than the very first element. If it is smaller, then we don't care about 1, then we get rid of 1. Okay, now this 9 comes in. Once again this 9 is actually greater than the very first element we have inside the main heap. So we are actually going to kick this element out, and we should be placing 9 in. But now once again the proportion of heap is going to change. This is going to become 7 and this is going to become 9, because currently 7 is the smaller element out of these two, and this is a min heap. Once again we have element number 8 coming in. So once again for this one we see that 8 is greater than 7, so 7 needs to be kicked out. Now where does 8 fit in this case? So 8 is actually going to fit over here. And notice that by doing this operation we actually did find a min heap of size 2. We are trying to find the second largest element, and the second largest element is going to be the first smallest element inside our min heap. That's it. This is the whole solution. You just figured out that how does the solution work, and we did what we wanted to do. You know, the funny thing is, even if we did not apply this property of like fetching the largest value out, still we would have ended up with this example and this option. So this is one of the very powerful way where you can start to think about using heap in order to solve all of your problem. And these are some of the most common type of problems inside the heap. So logically, the number one operation we can do is that we can add elements inside the heap. That is a simple task. Second option is that we can actually remove element from the root. So we can actually figure out that which is the smallest value and which is the largest value, and this removing element from the root is typically done in nearly constant time. So big O of one time we can do this operation. Now adding adding is actually done in big O of log n time. Why log n time? Because we have to do the heapify operation, so that's why it takes log n time. And even for the removal, we can figure out the value in big O of one time, but once again after removing we have to do the heapify operation, so that could potentially take big O of log n time. So in the worst case scenario, it is typically big O of log n. In the average scenario, it's usually going to be big O of 1 or around that time. Now the thing is, if we have to do a search operation that whether any element is present inside the heap or not, this is an expensive operation because we don't maintain any order inside the heap. All we know is that whether the parent is going to be larger or smaller than its child, but we don't know that what is the packing order, where does the value lies. So in the worst case scenario, this can operate in big O of n time, so you will have to be careful about that you should only be using heap when you are dealing with some sort of priority. And if you have some other operation like searching or things like that, then maybe try thinking about using a binary search tree or some other type of sorting mechanism, because that is going to be much more helpful. And now after this, if you have to remove or if you have to delete any specific element, then that is also going to be once again big O of n, because you will have to first search that where does that element lies and then removing that. And this is it. So now I hope that you understood that what is heap, what is priority queue, what are the differences, commonality, benefits, drawbacks, under what type of scenario should be using it. Now without any delay, we are going to be doing the 11 most asked, most popular and most like LeetCode problems. So let's get started with those, and then we would conclude this course. But in my opinion, you should understand that what is heap and how to utilize it in your best manner possible. Okay. So the LeetCode problem we are going to solve is called kth largest element in a stream. Now we can see that this one is a LeetCode easy problem and also an extremely well-liked problem on LeetCode. The problem statement is quite straightforward. We need to design a class where we can find kth largest element inside a stream, and we are told that we need to find the kth largest element in terms of sorted order number, not the kth distinct element. This is just to avoid confusion. Now let's see the requirements for kth largest class. Basically we need to implement two methods. First method is kth largest method, where as an input we are given an integer k and we are also given an integer array called nums. Now amongst these integer array nums, we need to return that whatever the kth largest element is. So suppose the given k is equal to 3, we need to return that what is the third largest element inside this array. Second one is an add method, where we are continuously adding value to a continuous stream, and in that continuous stream we are able to represent or return the kth largest element in that continuous stream. So with every new value being added, we can determine that this is the largest element inside the current k array. So for both the case, let's try to understand this with an example. Suppose this is the array we are given as an input, and we are being told that k is equal to 3. We need to find the largest element. Okay. So logically we can see that over here the largest element is 7, second largest element is 6, and third largest element is 5. So in this case we need to return 5 as the answer, that this is the largest element. Now say for the same example, this we took care of the kth largest element method, the first method. Now for the second method, the add method, basically let's say that we are given k is equal to 3. Okay, and this is a continuous stream. So first we add value number 1, currently we don't have any large value, then we add value number 2, and then we add value number 5. Now so far, what is the third largest value inside this continuous stream? So the answer is going to be 1. Then we decide to add value number 4. So once again, what is the third largest stream currently? So third largest value would be value number 2. So we will need to return 2. Let's say we add value number 3. So currently what is the third largest stream? So in this case, the third largest element so far amongst these 5 elements is value number 3. So we need to return this. So basically in both the cases, we need to find that for any particular given input, what is the kth largest element. Now for this add method, you would say that, hey, we need to check for every single time. So how can we do that? The idea would be to design a data structure where at every given moment we should be able to quickly identify that, hey, currently by adding this value to this particular data structure, the kth largest value is going to be either 1 or 2 or 3, depending on the number of elements that are currently present inside our existing stream. So let's try to see that how we can actually solve this problem. Okay, so if we see the brute force solution for this problem, brute force solution is actually quite straightforward. Let's say for given input array, we can simply start iterating over every single value in order to find the maximum value we found so far. Then we can repeat the same process to find the second maximum value, and then we can find the third process to find the third maximum value, and that would basically yield us the result of, let's say, if we are given k is equal to 3. This approach is very slow. Basically it yields in big of n square time complexity, so we definitely don't want to do that. So that is one option. Second option in this case is, let's say that for the same given input, if somehow we decide that we can actually sort this given input, then it becomes very easy for us to find any kth largest element. So let's say in this case, the sorted array is going to look like just all the values from 1 to 7. And in this case, the kth largest element, let's say our k is equal to 3, which means we need to pick the bottom third value in the answer, and we can simply return this one. So the sorting solution would work fine, but the thing is, in order to create like from this non-sorted array to sorted array, it's gonna take n log n time. So but this is still a much bigger improvement compared to our brute force approach, and this is actually what we are going to take into account in order to solve the problem. But the thing is, not only we need to create like a data structure where we can store the sorted value and find or calculate the result, but for our add method, because we need to continuously check for any particular existing value that is being added into the stream, that what the kth largest element is. So for every single time, doing the sorting would not make much sense. Rather, with addition of every single value, we need to keep track of all the largest values that we currently have so far. And for that, what I'm suggesting is that we actually use a very popular data structure called heap that is specifically designed to store or identify kth largest or kth smallest element. The approach I'm suggesting is that for this particular heap, we actually create a min heap of the size k. Okay, and what does min heap means is that it stores the values in like the minimum order in its sequence. So let's say currently in our array we have values like 2 and 4 and then 1, something like this one. So this is currently not sorted, but if we try to put these values inside the min heap, it is going to store values as 1 and then 2 and then 4. So basically we will have sorted values that are being stored, and adding every single new value inside the min heap only takes logarithmic time, so log n time. So the idea would be that if we just have a min heap of size k, that is number one scenario, and number two condition is that whenever we find a value that is actually greater than the current value we have, then we are going to pop this value out, and then whichever value x we found, we are going to push this value inside our array, and this should allow us to find the kth largest element very quickly. Let's try to see the solution I'm suggesting in action, and then it would make much more sense. So currently this is our given input array. We are trying to find the third largest element. So what I'm suggesting is to create a min heap of size 3. Okay, currently this min heap is empty. Now we have value number 4, so we simply add value number 4. Then we have value number 5. So remember, because this is a min heap, if there is like the low value, it needs to be at the very beginning. Okay, so then we add value number 5. Once again we have value number 1. So currently value number 1 is actually smaller than both 4 and 5. So we will min heap automatically would readjust itself, and we would have values 1, 4 and 5 stored in this manner. Once again, okay, so now let's say if up until only this point we want to find out that what is the kth largest element. all we need to do is just simply check that what is the very first element present inside the min heap, and that is going to be the kth largest element. So not only this min heap is going to allow us to calculate the kth largest element for given input array, it can seek subsequently applied in order to use for our add method as well. And that's why this one data structure is going to solve both of our problems. So now currently the kth, let me just put down the answer over here. Okay, that currently the minimum value is 1, so that we can find, and this answer is for the add method. And at the same time we will find this answer over here for the kth largest as a. Okay, that will come when we reach to the end of this given input. Now once again we have value number 2. So currently 2 is actually greater than the very first value inside our min heap, which means 2 should be in our min heap, and we are going to pop the smallest value inside the min heap. So now currently we have values 2, 4 and 5. Once again the answer is going to be 2, because this is the third largest element we found so far in this stream. Next we have value number 6. So the moment we want to add value number 6, which means 2 is definitely clearly smaller than value number 6, which means 6 needs to be added. But with addition of 6, 4 and 5 also needs to be readjusted. So now 4, 5 and 6. So far up until this point, the third largest element is going to be value number 4. Okay, once again now next element we need to add is value number 3, but currently 3 is actually smaller than the current value we have inside the min heap, which means we don't need to do anything. We can just simply skip over 3 as it would not be part of the solution. Next is value number 7. So for value number 7, once again we will have to do the readjustment. So 4 would be kicked out and 5 and 6 would be adjusted to have 5, 6 and 7. Currently our inside the stream the value is going to be 5, and the answer is also going to be 5. That 5 is the third smallest element, or sorry, third largest element inside the given array. So just by simply using min heap of size k, and then having the logic that if the value we are trying to add, if that value is actually greater than the current very first element inside the heap, we will need to kick this element out and insert this value inside the heap. Then the solution would work perfectly fine. If we see time and space complexity, in this case the time complexity is going to be big O of n log n, because for every single element we will have to enter it into inside the heap. So that's why the time complexity is n log n. If we see space complexity, it is going to be big O of k, where k is the kth element we are trying to find, because we are initializing a new min heap of size k. And for those who don't know, min heap also means a priority queue. So that's the logic right there. So first of all, we are going to initialize our priority queue and integer k, a couple of private variables to store them. Then we are going to have our kth largest method, where we are going to store the values of k and also initiate a new min heap instance with the size k. Then for every single element that is currently present inside the nums, we will need to add that value inside our nums array. So for that, rather than doing anything else, we can just simply use the add method. And now let's quickly also see the add method, where we first check that if the current min heap size is less than k, then we are simply going to add the value inside the min heap. If that is not the case, then we are going to check that if the given current value is greater than the current very first or smallest value we have inside the min heap, then we will have to kick that value out, and then we will have to add the new value we are currently at inside the min heap. In the end, we simply need to do a peek operation or the very first element that is present inside the min heap, and that is going to be the kth largest element for us. And that's it basically. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions, which is pretty good. It is excellent in terms of space complexity as well. And once again, the coding solution is present on our GitHub repository, so you can go and check it out from there. Thank you. So the LeetCode problem we are going to do is called last stone weight. Now, in my opinion, this is one of the most awesome problem I've seen. We can see that this one is an easy problem and also a very well-liked problem. The problem statement is that we are given an array integer of stones that defines the weight of every single stone that is currently present. Okay. Now we are playing a game with these stones. Now during the each turn, we choose the heaviest two stones. So this is the important part. We choose the heaviest two stones and then smash them together. Now the question is, there can be two possibilities. One possibility is that either for two stones X and Y, either both are of same weight or both are of different weight, which means one is heavier than the other. If both are of same weight, then both stones get destroyed. Okay, because we are smashing them together, both stones get destroyed. If that is not the case, and if we realize that one stone is heavier than the other, then the stone with lesser weight gets completely destroyed, and the stone with higher weight has a new weight that is like a y minus x. So whatever the difference between weight is between two weights, and then we are going to keep on repeatedly going to do the same process until the end of the game, where there is only one single stone left, and then we are going to see that what is the stone of what is the weight of that particular stone, and that's why the name is last stone weight. Now let's try to understand this with an example so it would make more sense. Currently we are given an array where every single value represents the weight of stones at that particular position. What are we being told? That we need to find the two heaviest stone during every single iteration. So currently two heaviest stones are going to be 8 and 7. So currently 8 and 7 are not equal to each other, which means when these two stones get smashed, this 7 is going to completely be destroyed, and this stone 8 is actually going to be only of size 1, because we will have to do 8 minus 7. Okay, following this particular condition. So once again, if we do that, currently we have this 7 gets completely destroyed, and we have this element number 8 that is now being turned into element number or stone weight size 1. So now the new array we have is values 2, 4, 1, 1 and 1 and 3. Once again, we are going to repeat the same process. So find the two heaviest stones that are 4 and 3. Once again, both are not same. So once again, if 4 and 3 gets collided, we are going to left with one stone that weighs 1 kilogram, and this stone number 3 is going to get destroyed. So the new array we are going to get is going to look like this, where the values are 2, 1, 1, 1, 1. Okay, so once again in this case, now this 2 and 1 are both are the stones, so they both are going to be crashed against each other. So if we do that, once again this stone will get completely destroyed, this one only becomes of weight 1. So new value is going to be 1 amongst these two, and then these 3 ones we already had. Okay, so now once again we are going to repeat the same process. Now two heavy stones are both contains the same weight. If the weight is same, both gets destroyed. So in the next iteration we are only left with two stones, 1 and 1. And once again, if we try to smash these two stones together, both will also get destroyed. So we will not have any stones left in this case, so we will need to return 0. Now let's say in the same condition, let's take one more example where we try to have some weight inside the stone. So let's say the values are, now in this case currently the two heavy stones are this 8 and 6. If both gets smashed, then we will have values with 2, 3 and 4. 6 will get destroyed. So once again the two heavy stones are 3 and 4. So once again, if both get smashed, then this 3 is going to be destroyed, and we are going to be left with values 2 and 1. If these two get smashed together, then this 1 is going to get destroyed, and last stone will only be left with size 1, and this is what we need to return as the answer. So basically this is what the problem statement is asking us to solve. The brute force approach is actually going to be quite straightforward, where at every single iteration we will first have to find the two heaviest stones. Once we find the two heaviest stones, then doing all the remaining work is not that much complicated. Then we can simply find the difference between them, and then once again create a new array, and then once again try to repeat the same process until we are only left with just one stone or no stones at all. So brute force approach would yield us the correct result, but the issue is, for every single time if we have to find the two heaviest stones for each of the remaining array, basically we are going to be doing big of n square work just to find the two heaviest stones. And once we do that, solving this problem is very simple and very easy to do. So the question we will have to focus on is that how can we improve upon the scenario where finding the two heaviest stone becomes very convenient for us at every single iteration. And for that, the idea is whatever the given input array is, we will actually try to create a priority queue or a heap where we are going to store all the values, and we are going to set up this heap to be of max heap type. So max heap means that whenever you try to add the values inside the heap, it is going to store the maximum element first and then smaller elements later, which means it is going to store all the values inside the descending order. Okay, this is the whole concept of max heap. So that's what we are going to use in this problem. And let me quickly show you that using max heap, this problem becomes really easy to solve. The idea is that first, currently we are simply going to iterate over every single values and start putting them one by one inside the max heap. If we do that, we will get a sort of I would say a value that is sorted in decreasing order. So very first element is going to be value number 7, and then we will have value number 6, and once again then we will have all the subsequent values in the same decreasing order. And this is the input we currently have. So once after finding this input, in order to find our x and y values, we simply need to poll these two values in. And after polling these two values, all we need to do is find that if they are of same size, then destroy both of them and move forward. If they are not of the same size, find that what is the delta between them, and whatever the difference is, try to put that back inside the max heap. Keep on repeating the same process until we are only left with just one element. And let's try to see the solution I'm proposing in action. So once again, in this case, currently this is our max heap, and currently these are the two largest elements, 7 and 6. We will try to pop them out, and we find that the difference is going to be 1. Okay, so currently this 7 and 6 has been popped out, and we have element number 1 that needs to be added. So in order to add element number 1, it will be added in the back side of the heap. So we will I will not draw a new heap. I will just keep on adding 1 values. Okay, and these are just empty shells, so don't just ignore them. Now once again, during the next iteration, we are going to find the two heaviest elements, that are 4 and 3. Once again, the difference is going to be 1. So once again, now we no longer have values 4 and 3 inside the heap, and we are just going to add one more element, 1, at the end of the heap. Next two heavy elements are 2 and 2. So because both are same, so we are simply going to ignore them and not add any other values. Now the two heavy elements inside the given heap are 1 and 1. Once again, both are same, so we are going to delete both of them and don't do anything. And lastly, there is only going to be one stone left, that is going to be of size 1, and this is what we need to return as the answer. So you realize that after storing all of this information inside a heap, that is a self-balancing data structure that automatically sorts itself with new elements being added, how easy this problem becomes. So once we implement the heap, this problem is very simple, and we know that insertion inside the heap takes log n time, and we will have to do it for n given input. So it's going to take n log n to store all the values and complete this problem. So this is going to be the time complexity. If we see space complexity, that is going to be big O of n, because we will have to create a new heap to store all of these values. So there is no other way to move around that, but still this is a very good time and space complexity. Now let's try to quickly see the coding solution for this one. Okay, so first of all, we are going to initialize our max heap, and this is how we actually initialize it using the priority queue. And in the comparator class, we are mentioning that only the maximum element has to be at the beginning of the heap. Then we are going to add all the values inside our max heap, and then we are going to continuously remove and smash the two heaviest objects until we are only left with just one element. And for that, we find our y as the very first element inside the heap, we find our x as the second element inside the heap. We simply have a condition that if x is not equal to y, then we are going to add the element, that is the difference of weight between y and x elements, back inside the heap, and keep on repeating the same process while the size of the heap is greater than 1. And the moment we reach to the end, we are simply going to check that if the heap is empty, we are going to return 0. If the heap is not empty, we are going to poll the last remaining element inside the heap as the answer, and that is going to be the heavy last remaining stone weight of our original input of stones that we were given. So now let's try to run the code. Seems like our solution is working as expected. Let's submit this code. And our code runs 98% faster than all the other solutions. That in itself suggests that we are doing something really good and really right. So once again, this coding solution is present inside our GitHub repository. You can go and check it out from there. Thank you. So the LeetCode problem we are going to solve today is called kth largest element inside an array. And we can see that this one is a LeetCode medium problem, also extremely well-liked problem. Now, in my personal opinion, this should have been an easy problem, but anyways, they have put it as medium. So let be it. We are given an integer array nums, and we are also given an integer k. Basically, we need to return the kth largest element that is currently present inside the array. Now let's try to understand this with an example. Suppose this is the input we are given. We can see that there are a bunch of different random values present at the random location. Now let's say for this problem we are given k is equal to 3, which means we will have to find the third largest value that is currently present inside the given array. Now we can see that the largest element is 7, so that is the first largest element, 6 is the second largest element, and 4 would be the third largest element. So in this case we will have to return 4 as the answer as the third largest element. Now let's try to find that what are the different approaches we can take to solve this problem. First approach comes to our mind is a brute force approach, where the idea is quite straightforward. We simply iterate over the given input array simply one by one, and in order to find the maximum value, then once again we iterate over in order to find the second maximum value, and we iterate over the third time to find the third maximum value until we reach to the kth maximum element, and we return this value as the answer. Obviously you can see that we are doing a lot of repeated work with the brute force approach, and the time complexity is going to be big of n multiplied by k, so that is not a good approach. Let's try to find the second solution. Now second solution is quite straightforward, that for this given input, if we somehow sort this given input, then finding the kth element is very easy, because then we will know that after sorting this, the largest element is going to be for the first one, and then we will have values stored something like this one, where we can easily find that which is the third largest element in just like that. So sorting will take big O of n log n time, and then finding this element will only take big O of k time, or just like this would be instantaneous because it's an array. Okay, so overall this is a good approach, works fine, but the issue is we are explicitly told that we need to solve this problem without sorting. So let's try to see that how can we actually solve it without sorting. For that we actually have two options. First option is that we find the most optimal way to solve this problem, that is using a priority queue or a heap. That is one way. And second option is that whether we use a quick select algorithm. So let me know in the comments if you want to see the quick select approach. I can also make a video on that in the future, but in this time we are simply going to use a heap. The idea is we need to find the kth largest element. So we are actually going to store a min heap, where we are going to store all the values in a min heap fashion, which means in a ascending order. Okay, so the very first element inside the min heap is going to be the smallest, and then all the other values are going to be larger than that. Next thing is we are going to have this min heap of size k. So we are only going to store k values at one time. And third thing is that in this particular min heap, we are going to have a condition that, let's say if a new value we are trying to add, if that value is x, if that value is greater than the very first value we currently have present inside the min heap, then we are going to kick this value from the min heap out and try to put x inside the min heap. So min heap once again is going to maintain its sorting property, and it is going to keep all the values inside the min heap or ascending fashion. So let's try to see the solution in action. So let's initialize our min heap. So currently the given k is equal to 3. So the size of the min heap is only going to be 3. Very first element is value number 4. The second element is 2. So once again we are going to store the values inside the ascending fashion. So 2 and 4. Next element is 6. So 6 would be added over here. Okay. Next value we are trying to add is value number 1. So once again 1 is a smaller value. So if one value is smaller than current max minimum heap, then we don't need to do anything. We can simply skip over. Why? Because we know that in this particular fashion, the third largest element is actually going to be the very first element inside the heap, and that is still going to remain 2. So we don't need to add value number 1, and we can simply skip over. Now we are at value number 7. So 7 is greater than the very first value inside the min heap, so we will have to kick this value out, and then we will have to put 7 in. But 7 would not be put in the place of 2. Once again we will do the operation of self adjusting the min heap, so values are going to be 4, 6 and 7. Once again, after adding 7, we have value number 3. So once again 3 is actually smaller than value number 4, so we don't need to add 3. Once again we have value number 2. 2 is once again smaller than value number 4, which means we don't need to add 2 as well. So after the end of iterating over the entire array, the very first element inside the min heap has to be the kth largest element, which we can see over here that this 4 is the third largest element inside our array, and that's it. So this is how easy it is to solve this problem using a min heap, and we can simply come up to the solution very quickly, very easily, without any delays. So let's try to calculate the time and space complexity in this case. The time complexity is going to be that we will have to iterate over every single element, and for that we will have to insert the values inside the min heap or do some sort of checking. So for n times we will have to do log n work. So it's still going to be the n log n time. It's still same as sorting, but the thing is, rather than sorting, we are using a priority queue to take care of the values inside the priority fashion, inside the min heap fashion. If we see space complexity in this case, space complexity is going to be big O of k, where k is the size of the given kth element we are trying to find, because we are initializing a new min heap to store the value. So it makes absolutely good sense to store this one. So we can see that this one is a really good time and space complexity to solve this problem. And once again, as a general rule of thumb, whenever you find any question where you want to find kth smallest element or kth largest element or kth biggest element, something like this, whenever you see kth, try to see that if you can use a heap to solve this problem, and almost 99% of the time you should be able to solve this problem. Okay, so now let's quickly see the coding solution for this one. So this is the coding solution. We can see that this is very simple and short coding solution. Basically, we first of all initialize our priority queue or min heap, and then we have a for loop to iterate over the given input nums that is provided to us, where we are simply going to add these values inside the min heap one by one. Then we are going to check for a condition that if the size of min heap is greater than k, then we need to poll the very first element that is present inside the min heap, and that's it basically. So in the end, we should have a min heap that only contains the kth largest element at the very first position, that we are going to do a peek operation and return. And let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. So our code runs faster than a lot of other solutions, and this is a really good approach. So I would be posting this solution inside our GitHub repository. So the LeetCode problem we are going to solve today is called k closest points to origin. Now we can see that this one is a LeetCode medium problem and also a very well-liked problem on LeetCode. The problem statement is quite straightforward. We are given an array of points that represents points on an XY plane or a graph. And we are also given an integer k. Now we need to return the k closest point to the origin. Now we are also given that what is the mathematical equation to point the distance between any two points, and that is the Euclidean distance formula. So that is x1 minus x2 square plus y1 minus y2 square and square root of the whole thing. So we need to say that, okay, say for an example, if this is the input we are given, we can see that there are a bunch of different points presented to us. Now I have plotted these points on this graph, and we need to return the k closest point to the origin. So origin is going to be this point 0 0. So origin point is always going to be 0 0, and we need to use the Euclidean formula. So let's say that we are given k is equal to 2. So we need to return that what is the second closest point to the origin. So we can see that in this case, this is going to be the first closest point to the origin, and the second closest point is going to be this one. So we need to return this value 2 and 1 as the answer, as this is the second closest point to the origin. Now in order to calculate the distance between any two points, let's say that we want to calculate this distance between this 1 point and 0 point. So the mathematical equation is going to be 0 minus the whatever the x square is, that is x minus 1. So 0 minus minus 1 and the square of this one plus, once again we will take y1 minus y2, so 0 minus this one is 1, so 0 minus 1 and the square of whole thing, and then we are going to do the square root of this whole thing. So that is going to give us this distance. That since in this case we are given k is equal to 2, we need to find the second closest element in order to, and return that as the answer. So in this case the answer is going to be 2 and 1 that we need to return. So that's it. This is the whole thing, that what the problem is asking us to solve. So brute force approach is actually quite straightforward. In the brute force approach, what we can do is we can simply start calculating all of these distances that are currently given to us, and then after calculating all of these distances we will have some random values, because for sure we are not going to get exact values, because we don't know which one is the closest, which one is the farthest. Let's say we find some random values, like let's say that this one is 3, this one is 2, this one is 1. I'm just giving some arbitrary values, okay? So something like these. Then once again amongst these values we will have to find that what is the second closest value. So once again for that we will have to iterate over the given array and find the second closest value. In order to do that, it can still take big of n square time in the worst case scenario, so we will have to do something better. So here now for the optimal solution, I have just put down like every single point denoted as a number, and for that number I have calculated that what is going to be the distance from the origin point for that particular value, and I have marked all of these values over here. Now say for an example, just for understanding's per sake, we will try to now understand that this one as if it does not contain a square root. Okay, this is just going to help us understand that what the solution is look like and how we can use max heap in this case to solve the problem. The idea is that we are going to create a max heap of size k, and inside the max heap we will always try to first add the value inside the max heap, and the moment we realize that the size is actually greater than k, then we will have to pull the lastly added element outside of the max heap. Okay, we are only going to store the k values. So in this case we are trying to find the second closest point to the origin, so k is equal to 2. So let's say let's quickly initialize our max heap, and inside the max heap currently we don't have anything. Now in the max heap we are only going to store two elements. Okay, I'm just adding one more element over here, because this is we will put down the buffer value to see if we exceed the size of the max heap. If we exceed, we are going to pop this element out. Okay, so now let's try to populate our max heap with the theory we just mentioned. So first we have value number 7, so we are going to put value number 7. Then we have once again value number 7, so we are going to put value number 7. Once again we have value number 2, so once again we will have to adjust the input. So it's going to be 7 and then 7 and then 2, but we exceeded our place because we only want to store two elements, so we are going to kick the 7 out and we are going to leave this as it is. Then we have value number 5, so once again this needs to be readjusted. So values are going to be 7 and then 5 and then 2, but once again we exceeded the number of inputs, so we will have to kick the 7 out. Now we only have value number 5 and 2. Once again we have value number 6, so 6 would come over here because this is a max heap, so we are following the property of descending order coming to the first. So the maximum value is going to be stored at the very top, and then once again we will have to kick the 6 out because we only wants to keep k is equal to 2 elements. Lastly we have value number 3, so once again first we will do the readjustment. So values are going to be 5, 3 and 2, but once again this 5 is excess, so this will also be kicked out. And then we are now done with all the values, and now we only have these two values inside our max heap, and the very first element inside the max heap has to be the kth closest element to the origin, and which we can see because this is the endpoint and the distance is square root of 3, and we can see that this is actually the second closest point to the origin after this one. So this is what we need to return as the answer. And this is the whole solution. So basically the important portion in this one is that first this problem looks complicated because we are dealing with like xy graphs, and I know many people after high school haven't even dealt with this one. Plus you might have forgot about the Euclidean distance equation, but don't worry, these are all just the constant matter. So all we need to do is, number one, we are going to iterate over the given input, and we are going to find that what has been the Euclidean distance from every single point to the origin using a simple mathematical formula, that is x1 minus x2 square plus y1 minus y2 square and the square root of the whole thing. Okay. After doing this one, we simply need to initialize our max heap to the values or size of k, and we are simply going to do the operation that we just mentioned. In the end, we can simply do max heap dot peak operation, and that is going to provide us the kth closest point to the origin. And that's it. This is the whole solution. So now if we see time and space complexity, in this case, time complexity is actually going to be big O of n log n, because it takes log n time to enter values inside the heap, and we will have to do this n times. Plus we will also have to spend some time calculating the distance from the origin to that particular point, but that is going to be constant effort that needs to be done for n values. So we can simply ignore this one because it is no longer relevant, because we already have a higher time complexity component. Space complexity, once again we will have to create an extra heap, so that is going to be big O of k. So now let's try to see the coding solution for this one. So the coding solution is actually quite straightforward. We are first of all going to initialize our max heap, and inside the max heap we are going to store the values based on the distance from the origin to that particular element, and that is going to be done based on using the Euclidean distance formula from the origin. And once we have those values sorted, then all we need to do is just simply add those values inside our heap. Now inside the heap, we will first add the value, then we will check that if the size of heap exceeds the value of k, we are going to poll the very last element we entered inside the heap, and that's it. Now in the end, we simply need to collect the kth closest point from the heap. So for that, we can simply create a result array, a 2D array, and we can simply run from I to the k, and we will try to find the element, and then we will poll it inside the result, and then we can simply return that as part of the result. So this is the whole solution. Now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared in terms of time complexity, and extremely good in terms of space complexity. So once again, the solution is present in our GitHub repository. So if you want, you can go ahead and check it out from there. Thank you. So now the problem I'm going to solve can be asked in three different ways in three different interviews. It can be a data structure and algorithm type of LeetCode problem. It can be a system design problem, and it can also be asked in low level design problem. So I'm going to do my best to explain in as much detail as possible. I hope you pay utmost attention to this particular problem. So the problem we are going to solve is called design Twitter, and we all know what Twitter is. This one is a LeetCode medium problem and also a very well liked problem. Let's try to understand the problem statement. Basically, we need to design a simplified version of Twitter where users can post tweets, follow and unfollow other users, and it is able to see the 10 most recent tweets in the user's newsfeed. So the Twitter class we need to create, we should be able to initialize the Twitter object. Then we need to create these four methods. First method is post tweets, where we are providing in the user ID and tweet ID that composes a new tweet with a new tweet ID by the user. Then we need to create a linked list type of structure for get news feed, where depending on the user ID we provide, it retrieves the 10 most recent tweet IDs in the user's news feed. Now for this 10 most recent tweet IDs, we are given some logic that each item in the news feed must be posted by the users who the user followed by the users themselves. Okay, so you should only be able to see the tweets that of the people that you are currently following. That's basically what it's trying to say. And this is the important part, that the tweets must be ordered from the most recent to the least recent. The latest one should come in first in your feed. So you need to maintain that timely order. And then we are being asked to create two simple methods, that is follow and unfollow, where you provide the IDs of follower and followee. And basically follower should start following with the follow method, and they should stop following with the unfollow method. So let's try to think and document all the things that we need to create. Okay, number one thing is we need to create a Twitter class. Now in this particular Twitter class we need to generate four methods. Now logically, first let's start thinking about each one of them one by one. So let's take the small problems first, because if you can't solve the hard part, solve the easy part first. Now for the following and unfollowing logic, basically we have two sets of users. So let's say that I am currently a user. Okay, now I am as a user, my name is Parth, and that's it. Now there are bunch of different users just like me that I'm currently following, and they also have their own white buckets of being users, and they might also follow me back. Some might do, some might not, and they may also be following bunch of different more users as well. So one logical conclusion would be that we want to make sure that the moment I provide you that any particular user, let's say Parth, and then I provide another user, let's say John Cena. So I should be able to see immediately that whether Parth follows John Cena or not. And I would like to do this in the quickest manner possible. So the only way to do that is that if for any particular user I create some sort of hashing solution, like a hash set or a hash map, where I provide the information of every single user that this particular user Parth is currently following. And in this hash set, then it becomes very easy for me to find that whether any particular user ID is being followed by this username Parth. If that is the case, then I can quickly add and remove those entries. So that way I should be able to tackle both follow and unfollow methods, because then it becomes pretty simple for us to identify that. But in order to accomplish that, we will have to first take in few accounts or few considerations. Number one thing is how we are going to configure our user details, like what are the items we should be putting in inside the user class. And for each user, because we are trying to create like a separate hash set, so how should that work? So we also have to think about that. We are trying to fix it using the users, and for every single user having a hash set of all the people that particular user follows. So for that, what I'm suggesting is that we first of all create a separate user class, and in this particular user class, that number one, we have the user ID, and then we also provide two methods. First one is a follow method, and second one is an unfollow method, where both the things this follow and unfollow method does is exactly to look up inside the hash set for that particular user and identify that whether there is a connection or not. In order to do that, we also need to have a hash set where we are going to store the values of all the users that are currently this user is following. That's it. So this is what our user class should look like, because we are taking care of the IDs and we are also taking care of follow and unfollow method. Now after tackling the issue of follow and unfollow, we need to also understand the logic of post tweets and get news feed. So now the next lesser complicated portion is post tweets. So now once again, now let me deviate slight bit of side from the users and also go into the issue of Twitter or tweets. So for any particular tweet, what are the different items a tweet needs? So number one thing a tweet has to consider is basically what you are trying to tweet, right? Of course. So in this case, we are being told that we are just posting an integer associated with that tweet. So basically a tweet ID. We are only going to be posting the tweet ID on what information is there, and that is sufficient. Okay, so every single tweet is going to have a tweet ID that we have to take care of. Next thing is, remember, when we are trying to generate the news feed, we need to provide the top 10 most recent news or most recent tweets. In order to do that, we have to identify that for these top 10 news feeds based on the time, we need to have some way to keep track of the timestamp that this tweet has been tweeted. So for any particular tweet, we will also have to keep track of the timestamp, that at what time did we created that tweet. That is numbers. Second thing we have to identify. Third thing is we have to associate that what was the user who created this tweet. So in order to do that, we can actually have the tweet ID, or we can have a post method basically on the user class, where we can simply create a tweet, and this post method should call this tweet method or this tweet class, where we are simply providing all the information we have in order to create a new tweet, and that's it. So now this tweet also has an access to the user ID, and this user ID and this tweet ID becomes our connection points to separate the tweets depending on per user basis. Because remember, when we get to the level of generating the news feed, we will have to generate the news feed based on the people I am currently following who have tweeted. So I need the information of the user, and I also need the information of the tweet, and I also need the information of time. So combination of these three attributes should take place into my tweet class as well. And next thing is for our tweet, typically tweets are generally stored in like a linked list sort of fashion, because even for the generate news feed, we have to create the linked list. So the ideal scenario is that even for any particular user that is currently generating a tweet, we also provide a link to call to the next tweet that this user also has made. So when we get to the coding portion, this thing would make much more sense on how we are configuring this user account and this tweet account. Now let me come back. Okay, now and also let me do a quick recap. So far we have created the users class, and we have also created a tweet class. In the users class, we are storing all the necessary information that we need for the user. So things like user ID, and then things like tweet that this user makes, and then what the hash set to store the information of all the people that this particular user is currently following. We also have the tweet table, where in the tweet we have the tweet ID. We also have the user ID, because we need to know that for any particular tweet what user was associated with that. And anyways, we are also having a post method that deals with the tweet class we have on our side. Remember, there needs to be a connection in this case. Okay, so that's why it needs to make sense. Once again, coming back for our tweet class, and also this is also going to be a time bound event, so we are also going to store time for each one of this one. Now coming back to our main Twitter class. Okay, we already took care of follow, and we already took care of unfollow methods. We also took care of how we are going to post tweet method. So basically, if we see the structure of the post tweet method in the original question description, we are simply providing the user ID, and we are also providing the tweet ID that this particular user is posting. Same thing, what we can do is, even for our post tweet method, we can simply provide in the values of the tweet ID and the user ID, and we can associate all of these things together. Now comes the tricky part, and the tricky part is that last thing is we need to be able to generate the news feed. Okay, so in order to generate the news feed, what we will have to do? So let's first try to understand logically what is being asked us to solve. We need to provide the top 10 or the most recent 10 tweets that were being made by all the people who I currently follow. Okay, so all the people who are followed by me. Okay, now this makes sense. Now let's try to visualize it. Currently I am the user, and for this particular user path, I'm trying to generate the newsfeed. This path is currently following 10 different people, and all of these 10 different people, they are also users on their own. Now these 10 people, whenever they tweet something, they would have a tweet associated with their user ID. Okay, and that association can be linked through the combination of user ID class and the post class, because remember, even in the user ID class we are actually calling a method to create tweets, and we can actually store those tweets inside the user ID. So user ID knows that for any particular user ID, what are the different tweets that that user has made. And let's say that some users just made one tweet, some user made bunch of different tweets, and then some user made few more tweets, something like this. So now we we can go to any particular user, that is option number one. Through this user we can find all the people I'm currently following, that is second step. Through finding all the people I'm following, I need to find all the tweets that they have made, that is the third step. After fetching, so let's say I identify that so far all the people I follow, they have in total made 50 different tweets. Now amongst these 50 tweets I want to find that what has been the top 10, or let me use, okay, most recent 10 tweets that has been generated. So for in order to find the recent 10 tweets, the logic is quite simple. I take all of these 50 tweets, I create a heap. Now we all know the concept of heap or a priority queue. Now inside this heap or a priority queue, I store the values based on the time they arrived in. So the value that came in at, let's say, time 1 second, and the value that came in, let's say, at time 3 second. So the 3 second should come in before 1 second. And this process can be easily maintained and manipulated by a heap, because it's a comparator type of data structure where you can compare between any two values and store the values in some sort of sorted format. So in this case, the sorting is going to be done based on the time that it came in, and it is actually going to be in the descending order. So the value that came in at the latest time should be at the beginning, and the value that came in later should be towards the end of the heap. And then once I have entered all of these 50 values inside my heap, then in order to generate the news feed, I simply have to fetch, or I simply have to poll the top 10 values, and that should be able to generate the entire tweet. So now I have some sort of rough way and idea to solve all these four methods. Remember, once again, let's try to reiterate. And the reason I'm doing this repetitively again and again is because this question is extremely important, and I really want you to understand the whole logic and the whole thought process, because we are using a great number of combination of data structures to achieve what we want. Okay, so for the unfollow and follow method, we are currently simply using the combination of that for any particular user is associated with a hash set of all the people that currently user is following, and then we can very easily follow and unfollow people around. Okay, in order to post tweets, we are simply relying on the concept or the connection between a user and a tweet, and we are combining everything based on the user ID and tweet ID. And even in the tweet, we are also associating the time associated with that particular tweet, so we can very easily put it inside the hash map. And the last thing is, in order to generate the news feed, we are working with a heap, and we are also working with iterating over any particular user. And for that user, we are going across all the people that this user is currently following, and after finding that information, going to those followers and trying to find all the tweets that they have made, put those tweets inside our priority queue or a heap, and then only fetch or poll top 10 out of this particular heap, and that should give us the generated news feed in a linked list fashion. But we still are missing one key portion. How would, in order to do these operations, how would we know that for any particular user, what are all the users associated with that, or how for user ID, what is the user ID class, and then what is the information being followed? So we need some sort of mapping structure over here as well. And for that, what we are going to do is we will first of all have to create a hash map, where inside the hash map we know that this is a key value based data structure. So as part of the key, we are going to have a user ID, and as part of its value, it is going to point to that particular user class or the user object that we have created. and once being connected to that particular user, then we should be able to find associated people that are being followed by that particular user, and the tweets that are being made by that user. And by going to those followers, we can also find their tweets and all of those things. So we are in now, in total, we are actually using like 5 6 different data structures. We are using a hash map, we are using a hash set, we are using priority queue, we are using what do we call linked list, and we are using like all sorts of practices to make everything work together. So this is a brilliant question in my opinion. This question can help you in a lot of different ways, and that's why I spent so much time explaining all of these different concepts and different scenarios. I hope you've understood my explanation. If you still face some issues, just write it down in the comment and I will be more than happy to answer your questions. But now I think it's time that we start seeing the coding solution for this, and it would start making more sense that why did we do what we did. Okay. Okay, so this is our Twitter class, and we first of all initialize a static timestamp, initialize the value at 0, and then we are simply going to update the value by 1, so we can keep track of the time. Now let's try to understand how does our user class looks like. As specified, we are going to have an ID for any particular user. We are also going to have a hash set where we are going to store all the people that are currently being followed by this particular user ID, and we are also going to make a reference to the tweet or the tweet class. Now let's see that for this particular user, we are also initializing a constructor where we are simply providing the value of ID, and we are also creating a new hash set for any particular user. Plus we are also adding the value of this particular user in the hash set, because a user should follow themselves. So that's a simple value. And then as a head of the tweet, or the very first element inside our tweet linked list, we are simply marking the value as null. Okay. Now for the follow method, we are simply adding the value to the hash set, this follow hash set that we have created. For the unfollow method, if the value does exist, we are simply removing that value from the hash set. So follow and unfollow are pretty simple from the point of view of our user class. And then we are also making one more method called post, where we are providing the ID, and we are creating a new instance or of a new tweet associated with this new ID that is being provided. And then we are marking the new tweet that we just created as the head of the new tweet. So we are just, this is just an intermediate step, but basically the tweet head is going to be the new tweet that we just created. Now let's talk about the second class, that was our tweet class that we talked about. Number one, we are going to have our tweet ID, or just like ID for this. Then we are going to be dealing with the timestamp. And since this is a linked list type of structure, we are also going to have one more node pointing to the next tweet in line. We are also going to have a constructor where we simply provide the ID of the tweet, and then we are going to add the value. We are also going to update the timestamp, and we are also going to point the next value to the null. Notice that we are already pointing to the tweet method using the user class that we have created. So we should be able to tweet for any particular user. Now we have, since now we have both of our classes ready, now we are going to generate a user map where we are going to have an integer ID as part of the key, and we are going to have associated user as part of its associated value. And now we are going to be working on our Twitter class. So first of all, we are going to initialize our initializing our hash map that we just created, and then we will start implementing all the methods that we talked about one by one. So first method is post tweet method, where we simply have a user ID and we simply have a tweet ID. So first thing we are doing is we are going to check that if in our user map, do we have this user ID as part of one of the users that we have created. If we don't have it, then we are first going to create a new user. After creating a new user, we are going to put that value inside the user hash map that we have created. And let's say that, so now we do have an existing user, and in either case, if we have, whether we have an existing user or not, we would create an existing user. Once that is done, For that existing user, we will try to find its information, and then we would call the post method inside the user that we have created. That is this method I'm talking about, where we are creating a new tweet. Okay, so this is how the post tweet method is going to work. Next logic is that we need to retrieve 10 most recent tweets in the user's news feed. So this is a complicated task. For that, number one thing we are going to do is have a linked list where we are going to be storing the news feed. We are going to check that if for this particular user ID, if we don't have it as part of the user ID, we can simply return a blank news feed. If that is not the case, we will first have to create a new hash set to store the information of all the users that are being followed by our user ID that is provided as part of the input. So we find that information. We also create a new heap or a priority queue where we are going to store the information based on the timing. So the value with higher timing would come in before, and the value with lower timing should stay on the backend side. Once we have all the data structures ready, then we are going to first of all go through every single users that we are currently following for this particular user ID, and iterating over each one of them, we will get all the tweets that they have created. So we are going to go over the tweet linked list that they have created, and if the given tweet is not null, we are going to add those values to our tweets. So now we have tweets being populated, and once we have those, then we are simply going to have initialize a counter. On top of it, we are simply going to check that while the count is less than 10, we are going to go over all the tweets. We are going to add all of those tweets to the news feed that we have created, and we are going to be updating the counter. And how we are going to be able to do that, because remember, inside our tweet heap that we have created, all the values are sorted in chronological order based on the most recent timestamp. And then once we simply check that if we find that the weather count is 10, then we can simply get out of the loop if that is not the case. And if the tweet.next is not equal to null, we will simply add that value to our tweet heap as well. And that's it. In the end, we can simply return the newsfeed. So we took care of the two most complicated problems, and then working on the follow and unfollow method is quite simple and straightforward. For follow method, we are first of all going to check that if the person who is trying to follow someone else, does that person exist or not. If that person does not exist, we will create them. Same way, if the person we are trying to follow, if they also does not exist inside our hash map, we would create them. And once they both exist inside our hash map, we are simply going to call the follow method for our user, and we are going to have like follower and followee setup. Same way, in the reverse order, we would simply call the unfollow method, and then that user would no longer be followed. And that's it. That is the whole solution. I know it looks complicated that we have to create a user class, and then we have to create a tweet class, and then we have to create a Twitter class, and then we will have to generate all of these four methods. But if you try to think it from the perspective of like regular logic, that if you are the developer of Twitter and you are trying to improve the system, or you are trying to implement it, how would you do that? So then you would gain much more beautiful insights from this problem. So let's try to run this code. Okay, seems like our solution is working beautifully. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions in terms of time complexity. It is also excellent in terms of space complexity as well. Once again, this solution is present inside at our GitHub repository. So the link is in the description. Feel free to go and check out that GitHub repository. I know it is going to be really helpful. And let me know in the comments if you find this question interesting. Did I explain it well? Did I messed up? Or whatever your thoughts are. Okay, thank you. So now we are going to do one of my favorite problems on LeetCode, that is called task scheduler. We can see that this one is a medium problem and also a very well-liked problem. Now I just have one request for you. I really want you to pay utmost attention to this particular problem, because if you can understand to solve this problem, there are a lot of important lead code concepts that would enshrine in your brain. So please, please, please pay utmost attention. Now let's get started with the question. Basically, we are given an array of CPU tasks, and each task is represented by a letter somewhere between A to Z. Then we are also given a cooling time n. Now we are told that each cycle or interval allows the completion of one task. Okay, that's fine. And then we are told that task can be completed in any order, but there is one small constraint regarding this interval n that we are given. And that is that identical task must be separated by at least n intervals due to cooling time. Okay, so let's try to understand what it just mentioned with some examples. And basically we need to return the minimum number of intervals required to complete all the tasks. So let's try to understand this with an example. In this case, we can see that we are given three tasks that we need to complete. First task is A, second one is B, and third one is once again A. We are also given the cooling down period of 2. Now, how does this cooling down period affect our task is that identical task must be separated by n intervals. So let's assume that during the first window, we start to complete task A. Okay, so we got rid of this task. Once again, we got rid of this task as well, task B. Now the thing is, we only have one task remaining that we need to complete. But if we try to complete task A over here, and if we see the difference between this interval and this interval, then we can see that the difference is only going to be 1. But the thing is, it has to be separated at least by 2, because that is what the cooling period is. Because once again, I'm repeating, both A and A are identical tasks. We are told that identical task must be separated by at least n intervals, and in this case is 2, which means two identical tasks has to be separated by 2 intervals. Currently we only have it separated by 1 interval, so we will actually have to add one more interval over here where we are not going to do anything. So this would be an idle period where we are just going to stay idle just to complete that one more interval. And now we have 1 and 1, 2 intervals completed after we completed task A, and then once again we can complete the remaining task A. So totally we need to return the minimum number of intervals required to complete all tasks. And in this case, we can see that we took 1, 2, then this idle third, and then this completing A4. So in total, we took 4 intervals to complete this task. Let's try to understand this with a couple of more examples. Next example is, once again, we are given n is equal to 2. Now in this case, we have 3 identical tasks. We have 3 A's and 1 B. So one logical solution would be, we can start with task A. Once again, we go to task B. Now we know that the cooling period is 2, which means we cannot use a task A once again. We will have to stay idle. So we got rid of this one. Okay, now once again we can do task A. But after completing task A, once again the next task we need to do is once again task A, for which we have to have 2 idle cycles. So since there are no other tasks remaining, we are going to remain idle for 2 more cycles, and then we are going to complete task A. So if we calculate in this case, we need in total 7 intervals to complete every single task in this input. And same way in this approach, we would actually need in total 8 intervals. How? Because we are given 3 A's and 3 B's. So logically we can do task A, then we can do task B, and then we cannot do task A or B once again. So we will do an idle scenario. Once again we would do A, once again we would do B, and once again we would do idle, and once again we would do A, and once again we would do B, and then we don't need to stay idle because we completed all these 6 of the tasks. So that's what the problem is asking us to solve. I know understanding this problem is quite tricky. Now first let's try to understand the brute force approach. Now logically, the most simplest brute force approach would be to try out every single possible permutations and combinations. So we start with task A, then once again we try to find that what is the next task that is not A. Once again we identify task B, once again we mark task B, once again we try to identify that is there any other task that we can do that is not A nor B within this 2 window period. We cannot find anything, so then we decide to go idle. once again we repeat the same process, and once again we keep on finding the next task. So this is a very slow approach, and we are doing lot of repeated work just to do this one, because number one, we are not sure that how many number of total tasks are available. Number two, we are not sure that what is the frequency of every single task. So we cannot know that during any particular interval cycle how many number of tasks we can accommodate. That is one huge problem with this brute force approach, and this problem is what we are going to solve and exploit it in order to make this algorithm much faster. So let's try to understand that what is the optimal solution I'm suggesting. But for optimal solution, first we will have to build up some logical understanding on how we can improve our solution. Okay, so for that, once again, let's take our favorite example where we are given 3 A's and 3 B's, and once again we are given our n is equal to 2. Logically, most efficient matter for us to solve this problem would be that in any particular given input, first we need to find out that what is the character that occurs most number of times, and we always have to start with that character in order to complete it in the fastest manner possible. So logically, in this case, both A and B occurs 3 times. So what I'm suggesting is that first approach we can take, first smart approach is that we can actually take an entire input, run it through some sort of like array or hash map, and create a frequency map. And in this frequency map, we are going to make sure that every single time any particular character, how many times it appears. That is number one thing. Next, we will need to learn that what is the maximum time any particular value repeats, and then we will need to store the values in the decreasing order. So once again, we will need to find some way to sort this frequency map. So for that, one of the very good approach we can take is that we can actually create a heap, where inside the heap we can store the information that how many times any particular character appears, and we can actually store its information. So let me just make this slightly different, and we are going to have B appear 2 times. Okay, so now it makes sense that A is 3 times and B is 2 times. Okay, now one more logic I'm suggesting is that we actually take understanding of this scenario, that what is this n represents. So basically this n simply represents that how many number of computations we can do back to back on separate characters during any particular interval size. But the interval size has to be n plus 1. Why n plus 1? Because remember, we want, let's assume, let's go back to our very first example. Now let's try to understand this logically. First, let's say we add value number A. Okay, then we add value number B. Okay, now how many more operations we can do where we can basically either there can be two options. Number one option is that maybe we have some other value that is not A and not B that we can add over here. That is one option. If that is not the case, another option is that instead of adding this another value, we will need to add an idle value over here, and then the whole cycle of once again reaching out to character number A would reset, because then we would have covered the two destination from this our original value A that we were looking at, which means that in order, depending on the value of n, we would actually have to consider the scenario of n plus 1 as part of one cycle, because in one cycle we can only take unique characters during that one cycle, and if we have less unique characters than this one cycle, then we will have to use idle cases. So which means if we have unique characters, we can simply reduce the values of those unique characters. So in this case, we got rid of this 1A and then 1B. So we are basically reducing the values. Let's say if this one was C, then we could have just reduced C, but we don't have C. So we still have A. So which means repeated characters would only be decreased by 1 during one n plus 1 cycle. And if we have unique characters, we will try to fit as many unique characters as we can inside this n plus 1 cycle. So this is the second improvement we are trying to do of applying n plus 1 cycles. So let's understood that number one, we already know that we created our hash map. sorry, we created our frequency map. Then we created a heap to store the frequencies that are coming in. And next we are going to be marking the scenarios based on n+1 cycles. Now these are the three improvements. Now I'm suggesting fourth improvement, and that's why I'm telling you that this problem is such a mind-blowing problem, because you are making improvements after improvements after improvements in order to make the efficient algorithm, and that's why you are learning a lot of new things. So that's why I'm paying my utmost attention. Coming back to the question, so understand in this case that so far we are keen on understanding that how many number of A's are present and how many number of B's are present and how many number of C's are present. The thing is, apart from storing this value inside the frequency map, we don't have any other information that we need to utilize this for. All we can do is that we are already tracking the values based on the cycles. We already have a heap to store the values in sorted order. Now, instead of storing these characters, why don't we just store the frequencies? Because in the end, we simply need to return that what are the total number of intervals we are going to need. So in the heap, we can actually store the frequencies. The idea is we are going to be traveling in the cycle by manner. So cycle in this case is this is 2. So there is going to be cycle of 3s. Okay. And we know that how many number of unique characters are present inside this given input, because inside the heap we only have two distinct frequencies. So that's why there are only two unique characters present. So this becomes our way to understanding that there are only two unique characters. We know that in one cycle we can only iterate over just unique characters and reduce their frequencies. For rest of the time we will have to put the idle slots. And what I'm suggesting is that we initially start our heap this way. Then we are going to run in the cycles of 3s. With every single cycle, we are going to pop the elements out of the heap to make sure that whether heap is empty or not. If heap is empty, if there are no values inside the heap, then we will simply add idle values till we make n+1. So why do we even make idle values? We know that after removing all the elements of the heap, basically for this cycle we still have some elements that for which we haven't calculated the frequency. And if there exists some frequency, which means the entire n+1 has to be part of the answer, and then we simply have to reduce the frequency by 1 and once again repeat the same process. So this is the whole solution I'm suggesting. Now let me quickly show you the optimal approach. Let's walk through the optimal approach and then we will see the coding solution. So if we see the optimal approach now, it is going to make much more sense. Once again, let's take our example and we have 3 A's and 2 B's and we have n is equal to 2. Okay. Logically we have our heap. So currently inside the heap we only have values 3 and 2, that is the frequency map. And notice that this frequency map is actually sorted based on the ascending order property. Then once again for n is equal to 2, which means we are going to do the cycles of value 3. Okay, so let's try to do the first cycle of value 3. During the first cycle of value 3, we are going to pop one element, this 3, out of our heap. Currently we have, and we are creating a temporary list to store the value of heap, and then we are going to reduce it out of the temporary loop. Okay, so currently this is 3, we popped one element out. Currently this is 2, once again we popped both the elements out, and we realize that currently our heap is completely empty. There are no values inside the heap. So if heap is empty, then we need to check that what was the value that we took out from the temporary loop. We took out the values 3 and 2, which means we will have to reduce these values, and reducing these values are going to be 2 and 1, which means the temporary list is not 0. So in this case, because temporary list is not 0 and our heap is empty, we know that during the first cycle we will have to do 3 intervals. So we are going to mark 3 that we have completed so far. So we are going to have a variable called interval where we are going to store the values. So far we have completed 3 variables. Once again, notice that inside the temporary list we first had values 3 and 2, but we reduced the frequency by 1. After reducing the frequency, once again we are going to populate this value 2 and 1 once again back into the heap. Once again we are going to run the operation. So once again in our temporary list we are going to have values 2 and then value 1 coming in, and we are also going to have a heap becoming empty. Now heap is empty, we try to reduce the frequency. So reduced frequency is going to be 1 and 0. Now, after reducing the frequency, we realize that there are still some values present, which means this entire interval we are also going to consider. So it is going to be 3 plus 3 so far. After this, once again, we realize that this value is 0. So 0 value we kick out from the temporal list. We put the value back inside the heap. So currently heap only contains value number 1. Okay, so now after containing value number 1, we will try to pop value number 1 out. Currently heap is empty, but we are not going to add 3 so far because this might be the last character, which is the case because in the temporal list we identify that there is only 1. If we do like a reduce operation minus minus, then this becomes 0, which means temporal list does not have any value and heap only had 1 value. So we are simply going to add that value that we take out from the heap or take out from the temporal list. So in this case, we need to make minimum 7 intervals to complete each of these cases. And let's try to walk through these 7 intervals. So of course, our given n is equal to 2. So first we are going to do operation A, once again operation B, and then we will have to do idle operation. Once again, we are going to do operation A, operation B, and our idle operation. So now, so far we have taken out 2 A's and 2 B's, and in the end we simply have our operation A we need to do. So total we need to do 7 intervals in order to complete this problem. And this is the solution. I know I went over a lot of things, but I hope that this made sense, that what I was explaining. If we see time and space complexity in this case, well, time complexity contains a lot of steps. So number 1 step is we need to build frequency map. That takes big O of n time. Plus we will need to iterate, we will need to generate the heap. So that takes big O of n log n time. Then we will have to run our while loop iteratively till we reach out, till we complete every single cycle. That is once again going to take big O of n, and then we will have to subsequently do the total number of intervals that we are going to be able to make, and that can, in the worst case scenario, it can be big O of n square. So in total, we can say that our time complexity is still going to be big O of n square, but this is much more efficient approach compared to our brute force that would have yielded us big O of n cube time complexity. So that was going to be horrendous. If we see space complexity, well, we are using frequency map and we are also using heap and plus temporary array list. So basically we are using big O of n extra space, and this is still, in my opinion, a good enough time and space complexity. So here is the coding solution. First thing we are going to do is, for given input task, we are going to run across and create a new frequency hash map where we are going to store the frequency for every single task or every single character. Once we have frequencies, we are going to build our max heap based on the frequency. So we are going to initialize our priority queue to store the integer values of the frequency sizes, and we are going to add all of these values from our frequency map, and they would automatically be sorted in descending order. Next thing is we will need to process every single task. So initially we are going to have our variable time set up as 0. Then we are going to have a condition that while our given heap is not empty, we will need to do the following. So first thing is that we will need to initialize our temporary list that we mentioned that we will have to create. Then we are going to run a for loop from I is equal to 0 to I is less than n plus 1, which means this is going to be one of our cycles. So this is going to be our cycle logic where we are simply checking that we are going to check if the max heap is not empty. We are going to keep on polling every single value out from the temporary list to the temporary array list, and we will keep on repeatedly doing it until our given max heap is either empty or we complete the n plus 1 cycles. In either case, we will have to add n plus 1 items depending on this. Then we will have to reduce the values from the frequencies. So because we are popping values out from our temporary from our heap, which means currently they are stored inside our temporary array list. So we are going to reduce the frequency and keep on checking that if the frequency is greater than 0, we are simply going to add that value to our max heap. If the value is equal to 0, then we are not going to add it to our max heap. Next thing is we will need to update the time, and the time update is going to be quite straightforward, that if the given max heap is equal to empty, then we simply need to update the size by n plus 1. If that is not the case, then we will need to update the size or update the time based on the temporary variable size we had, which means that was the additional values we found inside our temporary array list that got popped out of heap. And in the end, we simply need to return the time, and this should provide us all the intervals we had. So this was a brilliant question, a brilliant solution. Now let's try to run the code. Okay, seems like our solution is working beautifully. Let's try to submit this code. And our code runs pretty fast in terms of time and space complexity. Once again, the coding solution is available in our GitHub repository, and the link of the GitHub repository is in the description. So feel free to check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop LeetCoding till we get there. Today we are going to do a LeetCode premium problem, high 5, and though it seems like an easy problem, this actually covers a pretty interesting topic that is asked by a lot of FAANG companies, and that topic is max heap, min heap. So let's understand the problem statement. Essentially, we are given a two-dimensional array that looks like this, where we are given ID and score for different students that are studying in a class. Now we are given at least 5 scores or more for every single students, and which we can see over here, that over here we are given two IDs. So the IDs we are given are student ID 1 and student ID 2, and for student ID 1 we are actually given the results of 6 different scores, and for student ID 2 we are given the results of 5 different scores. Now our aim in this case is to calculate the average for top 5 subjects. So this is really important, that we need to calculate the average of top 5 subjects. So in this case, since we are given 6 scores, we only need to choose the top 5 scores and not all 6 of them. So this is the key point to understand. And we need to build a two-dimensional array in the result, and we need to return the result for every single ID. So ID number 1 and ID number 2. In this case, we need to return whatever the average we have found for top 5 subjects, and we need to return them in an increasing order based on whatever the given ID. If we take a look at this example, in this example for service ID number 1, we are given following scores. Since we are given 6 scores over here, we only need to choose top 5. So we are not going to choose this score number 60 because that is the lowest out of all, and we are going to choose the remaining 5 scores. So essentially we are going to do a sum of all these scores, and we are going to divide it by 5. So that will give us the average of top 5 scores for this one, and for student ID number 1, the average would be 87. Now we need to do the same calculation for student number 2. Now in student number 2, it's a little bit easy because we are only given 5 different scores, and we just need to do sum of those. So we don't have to eliminate any score, we can simply do sum of those to 88. So now we have reached the end of all the student IDs, and we have found the average. So in this case, we are going to return a two-dimensional array like this, and this would be our answer. So the first approach we can use is we can actually sort the given input, and we can sort the given input based on ID, and after we are done sorting it with using ID, we can sort it for every single ID, we can sort it using score. So that will make our lives easier. And suppose we are dealing with the same input, so we can sort this input as mentioned based on ID and score, and this would be the sorted input. Okay, so now since we have the sorted input, it becomes pretty trivial that how we are going to actually solve it. We are simply going to iterate over the sorted array, and for every single ID, we are only going to iterate over it just 5 times. So whatever top 5 values we found, we can keep on adding those top 5 values once we reach end of the loop and we are done with the top 5 values, we are going to divide it with whatever the sum we have found with value number 5, and that would give us the average of that particular id. And then we will move, then if for that id, if more entries exist, we are just going to ignore all of those cases, and then we will simply switch on towards new id, and we are going to keep on repeating this process. So let's see that in action. So basically for id number 1, we are simply going to iterate over. So we are going to find top 5 values, which are these values. We are going to keep adding them up, and after that we will divide it with 5. So for id number 1, we are going to find the average as 87, and then once we are at this stage and we have already calculated the average, if we keep iterating over our array, we are going to find that there exists one more entry with id number 1, which is this 60. And because this is already sorted and we have already calculated the top 5 entries that we could find over here, we don't need to use this case, so we can simply ignore the scenario and we would move forward up until we will find the next id. Now in this case, we will find the next id over here, this id number 2. So again for id number 2, we are going to do the same process. We are going to iterate over first 5 elements, and we will keep on doing the sum of their scores, and once we get the score, we are simply going to divide it with 5. So even for id number 2, we are going to keep adding all the values, divided it by 5, and we will find the average for id number 2 to be 88. Now since we have both of these answers stored, we can simply return, and will simply keep on adding a 2d keep on adding these values to a two-dimensional array, and we will simply return this at the end. So this would be 87, 88, and this would be our answer. Now we can notice over here that because we had the sorted input, it becomes pretty easy for us, and we can simply iterate over the sorted array just once, and then we will be able to generate this answer. Now if we calculate the time and space complexity in this case, well, the time complexity for this case would be actually n log n. And the reason it's n log n is because though iterating over this input, this sorted input is only n work, but the thing is we will have to first from this input generate the sorted input, and that actually takes big O of log n time, and that is why the overall time complexity is going to be n log n. And if we see the space complexity in this case, it would be big O of n as well, because we are creating an additional sorted array where we are storing all these values. Now in terms of time and space complexity, the next approach I am proposing is also going to be the same time and space complexity. So if you want to end your video, you can end it over here. There is nothing more optimal that is coming your way. So essentially in the given input, we are basically given two things, id and score. And the most critical part to solve this problem is actually to identify top 5 scores for every single id. And in order to achieve that, we have already tried sorting method, but the thing is there exists a better approach, and in that better approach what we are going to do is we are going to create a hash map. Now inside the hash map, we are going to treat id as key, so key would be id, and inside the values we are going to keep track of whatever the scores we are given for this given input. The thing is, the way we are going to keep track of the scores is actually a little bit interesting. We are actually going to keep track of scores in an decreasing order. So the way we are going to keep track of the scores in decreasing order will allow us to identify the top 5 scores in this case. That essentially for this scores, we will have some sort of queue or list, and we only need to select first 5 element, and we can ignore rest of them. So let's see that what I mean. So suppose in this case, we start iterating over this this input, and we will first of all check that whether id exists in this new hash set. If it does, we will update the value in the score. If it does not exist, we will add the value. So initially we find that the ID is 1. Now ID number 1 does not exist, so we will create an entry over here that ID number 1, and now the score we are given is 91, so we will just enter the score. Now again we identify ID number 1 and ID number 1 exists. Now the score is 92, which means that inside the scores we are putting a condition that we are only going to keep the stores in a decreasing order, which means that now we will have to update the score like this. Again we find ID number 2. Now ID number 2 does not exist, so we will have to make an entry, and score is 93. Now again the score is 97. So again, since we are keeping track everything in decreasing order, so we will have to replace the values. Now again ID number 1. Now this is 60, so 60 can directly be appended at the end of this whatever data structure we have. Now we have 77. Again we can append 77 over here. This one is 65 for ID number 1. Now 65 needs to go in over here, so we will have to update the value like this. And now this one is 87, so next value is 87. Again we will have to update the value like this. Now next value is 100, so for 100 we will have to update all the values. Now even for ID number 2 we have 100, so we'll have to update all the values. Last one is 76, so we can simply append that value at the end. And now essentially we have iterated over this input. We have created this new data structure. If you see the qualities of this new data structure, it serves our needs. Essentially we are given IDs. Now if you see the IDs, they are sorted in increasing order. So initially this is ID number 1, ID number 2. If we had ID number 3 over here, it would be placed somewhere at the bottom. If we see the number of scores, we are given for this ID number 1, we are given 6 different scores, but the thing is they are all in decreasing order, which means that since we are only worried about top 5 scores, we only need to select first 5 entries, and whatever the remaining values we can simply ignore that. Same we are going to do for this value number 2, that we are only concerned with this top 5 values, and if there existed any other values we would have ignored that, but that is not the case in this scenario. And now it becomes really easy for us to identify that what is the average of these 5 values, and we can simply do the sum of them and divide it by 5, and whatever average we find, we can just create our answer 2-dimensional array, and we can simply put it over here, so that for value number 1 the average is going to be 87, for value number 2 the average is going to be 88, and this would be our final solution. Now if we see the time complexity and space complexity in this one, first we will have to identify that how we are going to implement all of this over here. And the way to implement this is actually a hash map, but the thing is we are directly not going to use a hash map. We are actually going to implement a tree map over here. And why we are choosing tree map? Because tree map has a property that it automatically sorts all the values based on its ID or key. So since we already need that, so we are good with that. Now in terms of the second property for this tree map, we will also have to see that how we are going to store these values. Now these for storing these values, the important property we need is that at any point we insert any value, we will need to insert it in the right place, and we will need to maintain the decreasing order in this case. So in order to maintain the decreasing order, the best data structure to use this is to actually use a priority queue in this manner. And in the priority queue, we are actually going to flip the basic condition. Like originally in the priority queue, whenever you store the value, all the value gets stored in an increasing order. But the thing is over here, since we are using max heap, we are going to need decreasing order. So that's why we are going to revert whatever the entry we have for this priority queue. And this is how we are going to use an additional data structure to solve this problem. So now if we calculate the time and space complexity, for time complexity, essentially we are going to do big O of n log n work in total, because first we will have to iterate over this input that takes n work. Then we will have to create this tree map and fill in all the values. Also we will have to maintain the priority queue. that takes n log n work, and in the end we will have to generate this answer. So this takes n work because we will have to iterate over whatever this tree map is. So the longest work we are going to do is going to be n log n. And in terms of space complexity, we are creating this additional data structure to store all the values. So that's why we are going to use big O of n as additional space complexity. So if you see this, this is also same as our sorted approach. Like time complexity and space complexity are not different at all. But the thing is, in this approach, we are actually doing things pretty smartly. And as mentioned, like suppose rather than in this case we are given the problem for student and scores, suppose we could have been given the problem of any particular player and their goal scoring average. So we need to calculate something related to that. Or we could have given scenario where any company's stock performance over the last 5 years, and we need to select the top performing 4 quarters out of amongst those 5 years for all the companies, and we need to return them in a sorted manner. Like these are all the different ways where how this question can be framed, but we can actually use it and provide the answer using this max heap concept. Also, there is another way to solve this problem using min heap. So let me know in the comments if you want me to solve the min heap as well, and I can also show you that approach. First of all, we are going to create our tree map where in the key we are going to store the ID, and as the value we are going to store a priority queue. We are going to name it scores. Now we are going to iterate over the given input array, and we are going to store all the values to our tree map. So the first value inside the given input array at the 0th index is going to be ID. So we are going to create a new variable called ID. And the second value is going to be score. So first we are going to check that if the current ID already exists inside our hash map or not, and if it does not exist, we will add it there. And we are also going to initialize a priority queue to manage the heap property, where we are going to store all the values in a decreasing manner. And by default all the values in the priority queue are stored in an increasing manner. So this is the way to reverse that order. I'm sure that different languages will have different formatting, but that is the general idea. And once that happens, we are going to update the value of score for every single ID. Okay, now this hash map should have all the values stored, and now we simply have to iterate over it and generate our answer. So first we are going to create a list of integer where we are going to store all the answers. Now we are going to iterate over the new hash map that we have created. For every single ID, we are going to calculate the value of sum. So initially we are going to have the value as 0, and now we are going to iterate over the first 5 elements inside the priority queue, and every single time we are going to increase the value of sum. And since this is a queue, we are simply going to poll values every single time. And once that is done, we can simply store the results inside our list that we had created. And for the sum, we are going to divide it by 5 because we need to store the average. Okay, so now we are done with all our calculation. Now we simply need to create a 2-dimensional array, and store the value of whatever the answer we have found and return that. So we are going to name it as answer array, and now we will return this newly created answer array. And yeah, this should be our answer. Let's try to run this code. Seems like our solution is working. Let's try submitting this problem. Okay, our submission works pretty fine, and I would be posting this code in the solution or in the comments. You can check it out from there. And so the LeetCode problem we are going to solve now is called employee free time. With this one is actually a LeetCode premium problem, and that's why you see that this interface looks different. This is actually defined as a LeetCode hard problem, but in my opinion, this should have been a medium problem. But anyways, let's try to focus on what the problem statement is. Basically, we are given a list of schedule of employees that represents the working time for each of the employee. Now, each employee has a list of non-overlapping intervals, and these intervals are in sorted order for each employee. Okay. Now we need to return the list of finite intervals that represents common positive length free time amongst every single employees in a sorted order. Now in this list, we can see that we are given the working times for three different kinds of employees. So this is the timing for employee 1, this is the timing for employee 2, and this is the timing for employee 3. If we plot all of these timings on one single linear line, we can see that employee 1 works from 1 to 2 and then works from 5 to 6. So amongst all of this time, employee 1 is free. Same goes for employee 2. Employee 2 only works from 1 to 3. So apart from this, the entire period is empty for him or her. And this is the list or the timing for employee 3. So we need to find that what is the common free time amongst all of these employees, and we can clearly see that amongst this period every single employees are free. So this 3 and 4 is the interval that is common free time amongst all three employees, and this is what we need to return as part of the answer. So after understanding that what problem statement is asking us to solve, now let's try to realize that what is going to be the common approach we can take to solve this problem. First, you see that for any particular employee, this given intervals are in sorted order. That employee is working from 1 to 2 and then works from 5 to 6. Same way over here, though we are just given one single data set, but you get the idea that what I'm trying to refer. But the thing is, when we actually have to find the common intervals for each one of these employees or each one of these timings, question is, why are we even treating these as separate entities? Why don't we just consider that what if all of these intervals are just a simple intervals on a string or on a time frame, and then we just need to find that what are the common spaces available between each one of them, and that's the whole logic. So the idea is that for some reason, in order to do that, we will actually have to sort all of these timings that we are given for separate employees. Now sorting these can be done like couple of ways. Either we can just simply use like sorting function, or we can create an additional data structure where we can inject all of these values one by one, and we make sure that we try to sort them. So basically what I'm suggesting is that we use some sort of a heap or a priority queue. Now we know that the condition of a heap or priority queue is that whatever value you enter, it tries to sort it in some order. So we will try to actually sort all of these numbers in the ending period. So whichever one has like the earlier ending period would be sorted first, and whichever has ending period later would be sorted later. If we try to do that with this given input size, then we would find some results that looks like this. Now this is what our heap would have stored, that these are all the intervals we have, and currently we see that these are not independent intervals. There is a lot of overlap also present amongst these intervals as well, but this gives us much clearer idea on what we are trying to find. So now the logical step to do is that if we just try to go and start finding out that what are the free slots, then it would not work. Why? Because imagine over here we see that this one ends at 1 and 2, and then this one ends at 1 and 3. So we can infer that there is some overlap amongst these two. So we can deal with the overlap, and we can say that combiningly, like after 3 we can try to find some potentially empty spaces. Now after 3 we identify that for the next slot starts at 5. So this slot ends at 3, this slot starts at 5. If that is the case, we can clearly see that, hey, this 3 to 5 slot is an empty slot, so we can use this one. But this would not work. Why? Because for the next one we can see that this actually starts at 4. So this 3 to 5 is not a proper answer, and we can find many false positives. So before we start finding out the empty slots, we will have to do some work in between, and that work is actually quite simple. All we need to do is that every time we find an overlap, we simply need to merge those intervals. And how do we find overlap? Well, the answer is quite straightforward. If for one interval, if the ending period ends before the starting period of the other one, we can define that there is an overlap between those intervals. So if we do identify the overlap, what we need to do is, for the starting value we need to find the smaller value amongst both the intervals. For the ending value we need to find that what is the larger value amongst both the intervals. So if we repeat that scenario in this case, we can see that for this first scenario, this one ends at 2 and this one starts at 1, which means there has to be an overlap. So we encounter an overlap. So let's select the smaller value. So smaller value is going to be 1 because it's same for both, but the ending period is going to be 3 because 3 is the larger amongst both of them. So combining these two, we can just say that we only have one interval of size 1 and 3. Same way, this one is 5, 6. Okay. So currently this is 3 and this is 5. So there is no overlap. So this is a separate entity. Now amongst this 5 and 6, we need to check that whether this 6 and the next interval starts after 6 or before 6. So this one starts before 6. So because this one starts before 6, these two also contain some sort of overlap. Because there is an overlap, once again for starting pointer we are going to take the smaller value. So smaller value is going to be 4. So we are going to put 4 as the starting of the new interval, and for the ending point value we are going to use 10. So 10 is going to be the new ending interval, and that's it. After completely merging the all the overlapping intervals, we are only left with just two intervals. So this, now we can very easily process that this one ends at 3, this one starts at 4. So from 3 to 4 we have some empty slot that we can use. So that's quite simple, and this is what the whole solution is. So let's do a quick recap on what we just did. First of all, we use a heap to basically sort every single interval inside based on the ending order. So whichever was ending before would come first inside the heap. Okay. Next, we did the merge interval operation for all the overlapping intervals, and also we did that in like normal fashion. We simply need to iterate over the given values that are already sorted inside the heap, so that can very easily be done. And after merging, we only need to find the empty slots and put those empty slots in some sort of answer array list that we have created, and that's it. This is simply we can return. Let's try to calculate the time and space complexity. So in order to generate this process of sorting of every single value, it takes n log n work. Okay. After we are done with this one, we need to do the merge interval. So that takes big of n work. And after that, we need to find the answer or empty slots. That also takes big of n work. So overall, we can say that time complexity is going to be big O of n log n, which is quite good given the input. And this actually has practical applications as well. We see the application of this type of problem in all sorts of calendar and Google calendars and all the scheduling problems. So this is a real life scenario that we are solving in LeetCode. And if we see space complexity, well, because we are using an additional heap, it's going to be big O of n as well. So relatively this is good enough time and space complexity. Now let's quickly see the coding solution for this one. So first of all, we are defining our class interval, which contains the start and end value. Then we have our main solution where we need to return the list of free times for every single employees based on the given schedule. So first thing we are going to do is initialize a new array list to store the results. Then we are going to initialize our heap or priority queue, where inside the heap we are going to insert the values based on the ending pointing. So the value that ends first would be placed at the beginning of our heap, and then we are simply going to add all the intervals inside the heap one by one, irrespective of employees. After doing that, our heap should contain all the values in the appropriate manner, and then we are simply going to run a while loop, that while the given heap is not empty, we are going to check that what is the current heap and what is the current value and what is the previous value. We are going to check that if there exists any particular overlap or not. If there is an overlap, then we will have to select that what is going to be the appropriate end pointer. If there is no overlap, then we are simply going to add those values to our result array or result array list that we have created. And in the end, we are simply going to update the next and previous counters to update the values that we are fetching out of the heap. And that's it basically. So this is the whole solution. Now, unfortunately, I would not be able to run the solution because this is a LeetCode premium problem. But anyways, the solution is available on our GitHub repository. So if you want, you can go ahead and check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So in this video, we are going to do an awesome LeetCode problem called sliding window maximum. This problem has been asked at tons of different companies. It is extremely well liked and also a LeetCode hard problem. So without any delay, let's get started. Now let's try to understand the problem statement for this problem. We are basically given an array of integer called nums, and we are also told that there is a sliding window of size k, which is moving from the very left of the array to the very right of the array. So which means sliding window is moving constantly. Now we are told that we can only see the k numbers of the sliding window, and each time the sliding window moves one step to the right position. Now we need to return the maximum sliding window for every single sliding window that we have been able to find. So let's try to see some example for this given problem. So initially the window is going to be located at this position. Then window is going to keep on moving one step towards the right, which means this one is going to get eliminated and we would have a new window created like this. Same way, this 3 is going to get eliminated and we would have a new window created like this. For every single moment, we need to return the maximum sliding window. Okay, is that for this we will have to create another array where we are going to note that what was the maximum character for every single sliding window that we have been able to make. So the very first sliding window is going to be this portion 1, 3 and -1, which means the maximum value in this one is value number 3. So we are going to add value number 3 to our answer. Next, this one gets eliminated from the given input array, and then we will have a new window that appears of this size, which means once again the maximum value is going to be 3. So we are going to mark 3 as the maximum value. Next, for this window, now we have this value number 5 that is going to be the maximum window for the current given input. So now we are going to add 5 to our answer. Same way, we will also have 5 for this particular window as well, and we will add 5 once again. Now we also get rid of this element, and now we have this window to look after. So in this case, we have a new maximum value that is 6. And then in the end, we will have this last window where it contains 7 as the maximum value. And this is the answer that we will have to return in order to understand that what is going to be the maximum sliding window. So this is what is expected of us to return. For the brute force approach, the way we are going to do is that we are first of all going to create a window of size k. So suppose even in this case we are given k is equal to 3. We create this window, then we iterate over every single element and we try to find the maximum element. So we found maximum element as 3, so we mark that as the answer. Then we get rid of this one, we create another window and once again repeat the same process until we reach to the very end, and then we would be able to find the solution. Now in this case, the answer works perfectly fine, but the issue is for every single element we will have to iterate over 3 different elements to find the answer, and every single time we are creating a new window, which means the time complexity is going to be big O of n cross k, which is an expensive time complexity. So let's see that how can we improve on this one. One major improvement that we can make for this our given input is that instead of every single time creating a new window, what if we just use this logic of this existing window we already had and try to find the maximum value that we have already identified, and then move forward and then play around with that maximum value. That is one of the option. And this is going to be an intermediary step that we are going to use in order to generate the optimal solution. So that's why I'm explaining this approach. The idea I'm suggesting is that, let's say in this case, first of all, we have an element called max. This max element is going to keep track of the maximum character that we currently have inside our array as the window. Okay. And let's say that first, okay, currently we are at value number 1, which means we can only start adding the value after we have reached to the index value 2. So any value before that should not be added to the answer or should not be treated inside our answer array, but we can still keep track of the maximum element we have been able to find so far. So the idea is that first the value number is 0. Okay, currently maximum value is null, so we can add the maximum value we have been able to find so far as this value 1. Then we are at value number 1. Now once again this value is 2, so because 2 is greater than 1, so we will add value number 2 as the maximum element we have been able to find so far. Then we are at this third value, that is minus 5. So once again the maximum element we have been able to find is 2. So we are amongst, for this first window we will have to add one answer, and that answer we can directly take from our maximum element, so we can take value number 2. Next we will have to add one more element. So now we are at this value number 6. After at value number 6, this 6 is definitely greater than the current maximum value we had, so we can add value number 6 as the answer for this one. Okay, and now once again we will have to add the maximum value, so we can add value number 6 over here. Once again we find value number 7, so that is going to replace our maximum value, and then value number 8, that is also going to replace our maximum value, so we can add these values like this and build an answer. So you must be thinking that, hey, this looks quite straightforward, then why is it even this a hard problem? The thing is, we actually intentionally I chose an input like this because this is a very simple input where we don't have any particular issues. But if we are given an input, let's say now in this case, currently we are going to put our maximum value as this value number 3. Okay, and then now we are iterating over for this first sliding window, we will have to choose value number 3. But the thing is, we are not sure which value number 3 we picked. And in this case, let's assume that this becomes value number, instead of this being 4, this is 1. Okay, so let's assume that in this case, so far we know that this is the 3 that we added, but it could also be this 3. And now when we do move to the next element, which 3 do we have to remove? Because we are not keeping track of the index value of the maximum element, and that's why when our sliding window moves, we would be confused with this element. So that is a problem number 1. The second problem that we can think of is that we are not dropping the elements as we are moving forward. So every single time we move forward, we will have to drop all the elements that have already passed the given existing window, which means the approach that we found is to use the maximum element is correct. But the problem is that number 1, we are storing the value. That is an issue because we don't know that what is the index position. That can be fixed by storing the index position. But second issue is that we are only too much focused on just one character. Meanwhile, we should be focused on an entire window rather than just one character. And the approach of this window is very simple and very straightforward, that at every given moment, whichever the first element that entered inside the window would be the first element to be kicked out of the window when we move to the next window. So using these two approaches, what I'm suggesting is that instead of using a maximum variable just to store the value, I'm suggesting that instead of this, number 1, instead of storing value, we store index values. So index values will allow us to calculate that whether we are at the current window or not, which means it would help us to kick elements out. And second thing is that instead of only using one variable, because we are using an input of a window where we are continuously removing the previous elements, which means we are using the concept of first in first out for the current to maintain the current window, which means we can have a queue where we can keep track of the values that are currently present inside the given window. And we know the concept of queue is very simple, it's first in first out, so we can manage that. On top of it, inside the given existing window, we don't have to worry about storing all the three elements. We only have to worry about that what is the maximum element in any given window. So what we can do is that for our given queue, we will always keep track of the maximum element that we have been able to find at the very first location, so that we don't have to iterate over the entire queue to find the value. We can simply do a peek operation to see that what has been the maximum value inside the given sliding window. And now this should be able to solve a lot of the issues we were facing previously. So let's understand the approach I am suggesting. The logic is quite simple. Let's quickly take one example. Okay, so let's say that this is the given input that we are dealing with, and we are given that the value k is equal to 3. Now I have created an array to store our answer, and I have also created a queue where we are going to store all the values of the given current window inside the ascending order, and we are going to maintain the maximum value as going to be the very first element inside the queue. That is going to help us out a lot. Once again, I'm iterating. We are going to store the index values inside the queue, not the actual values itself, so we can quickly navigate that what should be the current window size. Okay, so I hope these things makes clear. And remember that since our given k is equal to 3, we can only able to start adding values after we reach to the index value 2 onwards. Okay, and I'm also creating one more variable I, just to understand that what is the current variable we are iterating over. So let's say that currently I is equal to 0 we are iterating over, which means this value. Now currently our queue is empty, which means we don't have any maximum values. So let's quickly add one value. So currently our queue contains just one element, that is 0, and I'm also writing the corresponding value 1 just for our sake of understanding. Okay, now we cannot add anything to the answer until this point, so we are going to move forward. Now once again we identified index value number 1 that contains value number 3. So this value is actually greater than the current value of the index position we have inside the queue, which means that we need to add this 3 over here. So we are going to add value number 1 as an index value, and which has the corresponding value 3. And we are simply going to remove this value number 1 or this index value 0 all itself. Why? Because for any given window size that we are able to create, it is always going to be that this is going to be the maximum element. So why do we even keep the non-maximum elements inside the queue? So the moment we are going to identify any maximum element, we are going to iterate over the given existing queue to remove all the elements that are going to be smaller than that for that particular sliding window. That is going to help us out a ton. Okay, so now we got rid of this element. Okay, now still we cannot add anything to the answer. So now we are at I is equal to 2 position. So currently this is value number -1. So -1 is actually not greater or smaller than the current maximum value we have inside the queue, which means we are still going to add it inside the queue as index value number 2, which contains value -1. But this would not be the first position. And now since at this I is equal to 2 position is equal to k is equal to 3, which means we are at our first window. Now whatever the maximum element we have inside our queue, at the very first position, we are simply going to peek that index value and then go back to our actual given input array and find that maximum element and put it in the answer array. So now we are going to put value number 3 first. Okay, now we are at index position number 3. So once again, index position number 3, the value is -3. Now what is the current maximum value we have inside our queue? That is index number 1, which means for our ith position, what is the sliding window? It is value 1, 2 and 3, which means the very first element inside the queue we have is still inside the valid window, so we don't have to kick that value out. That is number one thing we need to check. Next, we need to check the value for index I is equal to 3. So this value is -3. So because this value is -3, it is less than the current maximum value we have. We are going to add it normally inside our queue. So we are going to add index position number 3, which corresponds with the value number -3. Okay. Now, and once again we will have to add the maximum value, because now for every single value we are going to add one value inside the answer. And once again, for maximum value we are simply going to do a peek on very first element, that is our maximum value, and we are simply going to add it inside our queue. Okay. Now next we are at I is equal to position number 4. So now we are at I is equal to position number 4. For this one, the window size is going to be 2, 3 and 4, not 1. So 1 should be removed. And currently in the very first element of the queue we have value number 1. So which means we are going to remove value number 1 right here and now. Okay. Now after this we are going to compare the value that we currently have for this value number 4, that is this value number 5, and we are going to compare it with very first element. So since 5 is greater, which means the moment we identify that the 5 is greater, we are going to check every single element that are smaller than 5 and we are going to remove all of them. We don't need them inside the window because we are only keeping track of the maximum elements. So now we are going to store index number 4 that contains value number 5. And after doing this, we are going to once again add it to the answer. So we are going to add value number 5 to the answer. Next is element number 5 that contains value number 3. So once again, this particular value inside our queue, index number 4, is still part of the current sliding window. So now we are going to check the values. So 3 is obviously less than value number 5. So we are going to add value number index number 5 or value number 3 inside our given queue. And then once again we are going to add value to the answer, that is once again going to be value number 5. Now we are at this position where the value is value number 6, and once again I just for our understanding we are dealing with this window. So index values 4, 5 and 6. Okay. Now for this I is equal to 6, we will first check that whether 4 needs to be removed. No, it can stay there for now. Now we compare the value. So currently this value number 6, or the index I is equal to 6, contains the value number 6 that is greater than the index position 4 that contains value number 5. So we are going to get rid of this one and we are going to check all the values that are smaller than 6. So currently all of these values were smaller than 6 and we are only going to store index number 6, answer number 6, once again marking 6 as the answer. And lastly we are at I is equal to 7. So if I is equal to 7, then the valid queue or the valid window becomes 5, 6 and 7 index values. So the current index value we have inside the queue is 6, which is still valid. Then we compare the value. So 7 is greater than 6, which means we are going to replace 6 with value number 7, and which also coincidentally have the value number 7. And then because this is the maximum value we are able to find, we are going to also mark it to the answer. And in the end, we are just simply going to be done with our existing loop, and that's it. This is the whole approach and this is the whole solution that gives us the desired answer in a single iteration on the given input array. And all we are doing is just sometimes we are doing repeated work inside the queue to change the value of the array, but apart from that we are not doing anything. So this is a wonderful approach to solve this problem, and this is actually the optimal solution. If we see time and space complexity for this approach, the time complexity is actually going to be big O of n, because we are simply going to be iterating over this given input array once, which is pretty awesome and pretty convenient. So yeah, that's it. And in terms of space complexity, because we are using an extra queue, so that is going to be big O of k, because at max this can be of size q, nothing more than that. So let's try to run this code, and so now let's try to build the coding solution for this one. Okay, so this is the coding solution. First, we are checking for some edge cases, that if the given input is equal to null or if the given k is equal to less than 0, then we can just simply return a blank or an empty array. If that is not the case, first we initiate a variable to store the length of the array. Then we also create a new value to store the result of the given array. And then we are also initializing a dequeue to store the queue values that we just discussed in the solution. Now we are simply creating an array to iterate over the given list. Very first, we are checking that are there any indices inside the current window that are exceeding or that needs to be kicked out. For that, first we check that if the given queue is not empty and the very first element or the largest element inside our given queue, if that is less than the value of I minus k plus 1, if that is the case, then we simply poll that element out. If that is not the case, then we simply iterate over all the values that are smaller than the given current value. If we identify that scenario, we simply keep on iterating all the values and keep on removing them. Then we simply have to add the value to the queue, and we need to find the maximum value that is currently located at the very first location inside the queue to our array, and we simply add it after the value I becomes greater than the value of k minus 1 that we just explained. And in the end, our result array should have been populated, so we can simply add all the values and return that. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs extremely fast compared to a lot of other solutions. Once again, the coding solution is present on the GitHub repository that we have created, so you can go and check it out from there. Thank you. We are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do top k frequent elements lead code problem. And if we see some of the companies where I want to get a job who have already asked this question, there are companies like Facebook, Amazon, Microsoft, Google, Uber, Apple, Bloomberg, Snapchat, Twitter, Tesla, Netflix, ByteDance, LinkedIn, eBay, and TikTok. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also a very well-liked problem on LeetCode. Basically, we are given an integer array called nums, and we are also given a separate integer called k. Now we need to return the k most frequent occurring elements from this nums array, and we are also told that we can return the answer in any order. So first, let's try to understand this problem with this example. I have actually drawn it much bigger over here. So this is the array nums that we are given, and we are given k is equal to 2, which means we need to return top 2 elements that are present inside this given nums array, right? So if we see in this case, well, over here, this 1 is actually present 3 times. This 2 is actually present 2 times. This 3 is actually present 1 time. Now, if we see, we are given that k is equal to 2, which means we need to return top 2 elements. And clearly we can see that the top 2 elements in this case is this 1 and 2. So we can return the answer to be 1 and 2. Or we can also return 2 and 1, because remember, we are told that we can return answer in any case, and this is the answer we need to return. So let's try to see that what is going to be the approach to solve this problem. Now let me make one clarification. There are actually 2 different approaches to solve this problem. One approach, or the first approach I'm going to show you in this video, is actually sufficient for your interview. Any interview would be more than satisfied with that approach. But the thing is, the second approach I have is actually the golden key approach for any like top k element problems, right? Any heap problems, you can use the second approach. And I'm actually planning to make a separate video on that, depending on whether you want to learn it or not. So let me know in the comments that whether you want to learn this second approach. If you do, I'll make a separate video. We are actually going to use the combination of a hash map and a heap in order to achieve the top k elements. So I have created a custom example over here, and I have given the value of k is equal to 3. Now remember, whenever we need to define that, we need to return top k elements or top 3 elements in this case. How can we define that? Well, we first of all need to iterate over this given entire array. We need to find that how many times any single character is occurring, and depending on that answer, we will have to iterate over that whatever the list we create, where we have the number of occurrences for each character, and then we can conclude this answer. So one thing is clear, that we need some way to store the information that how many times any particular individual character occurs. For that, we are actually going to use the hash map. In the hash map, as the key, we are going to denote the distinct value of this given array, and as its value, we are going to note the occurrence of that particular character. So first, let me quickly create a hash map for this given input, which contains the distinct values and their occurrences. So based on this given input, this is the hash map we can create. Now we need to select k is equal to 3, which means we need to provide top 3 elements. Now one approach to find the top 3 elements is that all the distinct values we have in this hash map, if we just simply create a sorted array, and in the sorted array we sort the arrays based on the descending values, which means the most occurring value to be first, and then we put down all the remaining values, we can actually generate a sorted array that looks like this. And now for this particular sorted array, we can simply return the top 3 elements. So we can return the answer to be like 4, 3 and 5 easily. And this is the solution that would give us the correct answer. But thing is, you would quickly ask me that why did I mention priority queue over here? Because over here, what I'm doing is I'm taking this hash map and I'm actually just sorting it, and we are able to generate the array. Well, first of all, in order to understand that, first of all, let's understand the time complexity of this approach. The time complexity of this approach is, first we need to iterate over the given entire input. For that, it takes big O of n time to generate this hash map. After generating this hash map, we will have to create the sorted array that takes n log n time to generate that answer, and this n log n is going to be the ultimate time complexity. So the thing is, this you would say, hey, n log n sounds reasonable, but the thing is, from n log n, suppose we have like 1 million distinct characters or 1 million characters, and we are given k is equal to 3, which means that we would have done like 1 million times log 1 million work. Meanwhile, the value of k in practice is supposed to be much smaller than whatever the input size is going to be. So the other approach is that if we create a priority queue, and remember, the concept of a priority queue is that inside the priority queue, basically we add the values and we remove the values, just like any queues. But thing is, the values that we are entering, they have some meaning behind them, and depending on their valuation, we actually store the value. So whenever over here, suppose this is the priority queue and I have provided different weight to those elements. If I want to create, or if I want to enter an element that is in higher weight, then I would get rid of only the lower weight elements and add those over here. I would not be repeating everything. So based on that concept, what I'm suggesting is that rather than sorting this array, we get rid of it. Okay, so let me clean this up a bit, and over here from this actual hash map that we have created, we actually create a priority queue. And this priority queue is going to be of whatever the size we are given of the k value. Okay, so k in this case is 3, so we are going to only have 3 values in our priority queue. Now for our priority queue, first of all, we are going to check that, okay, we only enter the values based on the number of occurrences they have, and we only keep the higher number of occurrences. So first we add the value number 1 over here because we don't have anything. Now we add value number 2 over here because we still have room and 2 has 2 occurrences. Then we add value number 3 because 3 has 3 occurrences. And remember, we are using the occurrence to add the value, not the actual distinct value, right? This is the key part. Okay, now we have this value number 4. 4 actually has 4 occurrences, right? And so far, if you remember, this 1 had 1 recurrence, this 2 had 2, and this 3 had 3 occurrences. Now we have a value that is 4 that has actually 4 occurrences, which means it is greater occurrences. So we are able to insert that value inside our priority queue, and in that case we are actually going to get rid of the smallest value. So smallest value in this case was 1. Now we are not going to add 4 over here, but we are also going to maintain the ascending order in terms of the values that we are being added. So we'll just shift these values. Okay, so 2 will come over here, 3 will come over here, and 4 will come over here, and then we will have those subsequent values. Now after adding this, we still have value number 5 that we need to add. So 5 occurs 3 times. So 5 occurs 3 times. Currently we have 2 occurring 2 times, 3 occurring 3 times, and 4 occurring 4 times. Now 5 occurs 3 times, so 5 is able to enter over here because it occurs more times than this 2, and we can actually put 5 over here because it is also occurring 3 times, and this 3 is also occurring 3 times. So we are good up until this point. After that, all we will have to do is just convert this result into an array. So for that particular array, we are actually going to store the results, and remember, we can return result in any manner. So we can return like 5, 3, 4, or we can also return like 3, 4, 5, or whatever result we want to return, we can return. And this is going to be the solution. If we see time complexity in this case, the time complexity is actually going to be a bigger improvement than our sorted array approach. Why? Because okay, over here this takes big O of n time to generate this hash map. That process remains same. But now from generating this hash map to this priority queue, it takes n log k times because we are only maintaining k elements. This is the important part, and this is what your interviewer is going to focus on. So in this case, the time complexity is actually going to be big O of n log k, which is good. And in terms of space complexity, well, you must have guessed it correctly. It's big O of n because we are using a couple of additional data structures. We are using a hash map, and we are also using a priority queue. And this is a very good time and space complexity. And that is basically the ideal approach. Now let's move on to the coding. First of all, we are going to take care of an edge case that if the given k is equal to whatever the length of this nums is, we can simply return nums. That is not the case. We are going to initialize our hash map. Now we are going to iterate over all the elements that are present inside this given nums. So we are going to run a for loop, and after the for loop ends, we are basically going to populate the values inside our count hash map that we have just created. Now we are going to initialize our priority queue. And inside our priority queue, we are going to assign the method of insertion. So we are inserting based on the number of occurrences based on this count hash map. So let's put the condition for that. So now now everything is set up. Now all we have to do is just iterate over all the keys that are present inside this count hash map that we have created. And for every single key, basically we are going to add that value to our heap priority queue. And whenever the priority queue gets full to the size of this k, we are basically going to pop the element. And the element that will get popped is going to be the least occurring element. So we are only keeping higher occurring elements inside our heap. And now we check that if the heap size becomes greater than k, we remove the value from heap. That's it. So now all we have to do is just simply initialize a new array variable called answer, and we are going to populate this answer array. So we will run a for loop for k times, and we will keep on pulling the values from our heap. Then we can simply return the answer. And let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs pretty efficiently, and I will be posting this solution in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. So the lead code problem we are going to solve today is called find medium from a data stream. It is a very nice problem. And if we see some of the popular companies where I want to get a job who have already asked this question, there are companies like Amazon, Apple, Uber, Adobe, Bloomberg, Google, Spotify, Microsoft, Facebook, Nvidia, ByteDance, LinkedIn, and bunch of more. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem and also a very well-liked problem. Basically, we need to find the median from an incoming data stream. Now, in this problem, basically we are being asked to implement the median finder class. Now in this median finder class, we need to implement these three methods, where the first method is the median finder method by itself. Second one is a void add number, which means that if this method is being called, it will add an integer called nums from the data stream to our data structure. And third one is the find the median, that we need to basically find the median. Now let's come back to the problem statement. First, we are given the definition that what a median is. Median is the middle value in an ordered integer list. Now this is the tricky part. We are being asked to find the median from an ordered integer list, which means that the input, whatever the input comes, let's say the input comes like 11, 3, 5, something like that, we still need to find the median as if the input was 3, 5 and 11. So this is the tricky part. Like most of the people would not realize that the wording ordered integer is there, and then they will get confused. So now we have get that sorted. Now we need to see that what is the definition of the median is. Basically median is the middle value, and if the size of list is even, then which means there is no middle value. In that case, we need to find the median as the average of two middle values. And we are given some examples, but we are going to see this in much broader examples. So first let's try to understand this with some existing example. Suppose we are given a stream that looks like this: 1, 2, 5, 11, 15, 16, something like this. what would be the median in this case? Well, if we go based on the definition currently, well, this stream is actually an even stream, which means that there is no exactly one middle value. We are currently seeing two middle values in this case. And also notice that for this whole thing, I actually set it in ordered motion already. So we are going step by step. So first, this is an ordered list, that is an even list, and it has two middle values. So in this case, the median is going to be the average of these two values. So which turns out to be 5 plus 11, 16 divided by 2. So the answer is going to be 8 in this case. So second, again, let's suppose that once again the list is ordered list. So 1, 2, 5, 8 and 9. In this case, we are dealing with odd numbers. Now for these odd numbers, the middle value is quite obviously clear, and that is going to be value number 5. And again, the ordered property is still maintained in this example as well. So in this case, the answer is going to be simply value number 5. Now let's take one notch a little bit more complicated. What would be the median in this case? Since this is odd number, we know that we need to find the middle value, but in this case, this is not in order. So first we will have to put this in order. So that is going to be 1, 3, 5, 8 and 15. And in this case, now since it is easy to calculate the middle value, it is going to be 5. So this would be another scenario. Now with these examples, you at least got one broader idea that how to deal with the median finder class. Like when we need where we need to first of all create a method to find the median. Second, we need to create a method to add the median. And third, we need an object of this median finder class. So basically we need to focus on these two items the most. Now the most important part in this one is first we will have to see that what would be the actual problem is going to look like. So actual problem is going to look something like this, where there can be multiple options. So first, let's say that it selects and the option is that you need to find the median. But currently, if we see our list or our input data stream, let's just mark this as input data stream. Currently in our input data stream, there are no values, which means if we call out this find median function, basically it is going to return 0. So this time, or return null value, actually not 0. So let's say that this returns the value null. Okay. Now again, we are calling add number method. So if we call add number method and we say that, okay, add number 5. So in this case, currently in our data stream, there is only one value, that is 5. Now we call add number method again, and we add value number 6. So now our data stream has value number 6. Once again, we call the add number method and we add value number 2. So in this case, currently our data stream has value number 2. And then if we call the find median method, which means we will have to find the median. Now in this case, ideally this find median method should give us the answer according to all of these examples we saw. So basically, first for this data stream, it's 5, 6, 2. So we are going to put it in the ordered list, that is going to be 2, 5 and 6. And the answer in this case needs to be returned as value number 5. So 5 is what we would return over here for the find median. Now again, there can be bunch of more operations to be performed same way. So let's say that again we add a number and this time we add the number 11. So our data stream is going to have value number 11. Now if we want to find the median, then again there would be an additional bit of changes. So it would be like this would be our sorted data stream, and the median is going to be 5.5, and this is what we will return. So basically it will keep on changing. Now our job is to do this in the most efficient manner. Okay. Now in this array list, what we are going to do is from whenever our main method, whenever we see add number method being called, we are going to simply push one number down this data structure. So let's say we got numbers coming in as 6, 8, 2, 1, 5. Okay, this is the sequence of numbers that came in, and then we encountered the find median method. Now again, since this is a brute force approach, we are going to take this step by step in the very preliminary fashion. So first thing that we would do is that we need to find the median of this array list, but currently this array list is not sorted. So because this is not sorted, we are going to simply sort this. Now sorting an array or array list, actually there are a bunch of different ways, but typically this can be achieved in n log n time if we use something like quick sort or merge sort. But we are not even going to bother implementing those quick sort or merge sort. What we are simply going to do is call collection.sort method. So if we call collections.sort method in any programming language, basically it sorts the given array for us in n log n time. So after that, we are going to have a sorted array, and the sorted array is going to look something like this. It's going to be 1 2 5 6 8, and this sorted portion took us n log n time. Okay, now for this 1 2 now finding the median, it becomes quite simple, because we know that for array, fetching takes big O of 1 time, and also putting the value takes big O of 1 time. We already know the size of the array, so in this case the array size is going to be 5. So because array size is 5, we know this is odd number, and since this is odd number, we need to find the middle value. So middle value has to be located at position number 3, or if we see in the array, it has to be sorted array, and the index value has to be 2. So because this is 0 1 and 2, and whatever the value is located over here, we are going to simply return that, and that is going to be our answer. So let's break down how does our brute force solution compare to everything we have done so far. So it actually seems to do justification, because if we see in this case, the finding median is being done through two processes. First process is that we are sorting the given input, and second process is that we are actually finding the median by doing the average depending on the odd or even value. Now this case is a constant operation, so this can be done in big O of 1 time, but the sorting is actually a little bit tricky, and this takes n log n time. So overall, the finding median is going to be done in n log n time, and adding number is actually quite quick, so that is being done in big O of 1 time. So if we see the total time complexity in this case, the total time complexity for this brute force approach can be considered as n log n, and that is not so bad. But we want to do it in much faster manner. So we will have to strive for something that where we can store or where we can save in terms of time complexity. Well, optimal solution is actually comprised of couple of different components, and what those components are, first we will have to find the room that where we can actually save in terms of time complexity. So we are currently taking care of finding median by using first sorting the given input, and second one is finding the actual median. Now this portion is quite easy, so we can ignore this one. This portion is the trickiest. And why this is the trickiest? Because we actually have an incoming data stream that is generating bunch of different random numbers, and we are taking these random numbers and creating them in a beautiful sorted list, and this sorted list is then being used to find the median depending on the middle values. Now since we already know that the input that is coming in at one at a time, so if the input is already coming at one at a time, why can't we design a structure that automatically sorts itself, and we are not going to need to care about the sorting property? So we already took care of one portion of it. And what would be that automated sorting mechanism data structure is? Well, you already know it. It is actually called a heap or a priority queue, where depending on the how you configure it or how you set up, you can actually configure it to have in either in increasing order or decreasing order. So no matter the sequence of numbers that are coming in at random, eventually this is always going to be in the sorted manner. So if it is always going to be in a sorted manner, then it becomes very easy for us to basically find the median, because we already know that how to find the median from a sorted property. Now there are a couple of tricky parts over here, and first let's break those down. Currently we have already decided that we are going to use heap. Now what are the trade-offs with heap? Well, the first trade-off is that if we want to insert any data, basically the insertion takes big O of log n time, right? So that is adjustable because it is maintaining the sorting property. So how it does it is that let's say that you have this initial heap that is being created, and currently this heap is empty. Now you have this one incoming value 15 coming in. So 15 comes in. So it currently, because there are no values, it puts 15 as it is. Now let's say that there is one more value coming in, and that is value number 16. So now for this value number 16, heap is not just going to append it anywhere in the sequence. It is going to see that, okay, let's assume that this is actually a min heap, which means that the topmost value has to be the minimum value, and all the other values would be greater than that. So in our min heap, basically we need to make sure that the first value remains the smallest and everything is sorted in increasing order. So in this case, because of this is a min heap, it is going to put 16 over here, and 16 is going to stored over here. Now suppose we have another value coming in, and that is value number 5. Now this value number 5 is actually lesser than 16 and 15 both. So in this case, it is actually going to find a proper bucket or a proper place for 5 to be stored, and that it is going to do using the binary search. And we all know that binary search takes log n time. So that is why first it is going to do the binary search to calculate that where to put this 5. It calculates that, okay, currently the 5 is the lowest or the minimum value, so that is why it is going to put 5 at the beginning, and it is going to take care of all the other values. So basically our heap is going to look like 5, 15 and 16. And because of this property, there is this log n time penalty that we have to pay. But this log n is actually much better than n log n because we are only doing it once. So that is the trade-off. Now I hope I was able to explain you that how does a heap work. Once we have that sorted, now let's see that will this make any improvement to our problem? Well, of course, it is going to make significant improvements to our problem. Currently, let's assume we are using a min heap. Again, using the same example, let's say that we have our data stream. Now in our data stream, assume that we have all the values coming in at random. So the random values that are coming in at the moment are going to be, let's say 1, 15, 3, 8, 9, 11, 13. Okay, these are the random values came in, but we have a heap and we have a min heap, which means it is going to take care of all the values in the sorted manner. So sorted manner is going to be, now in this case, since we have 7 digits or 7 values stored inside our heap, which means that this is odd number. So because this is odd number, we need to find the middle value. Now this is the tricky part. We know that with array, it was actually easy to fetch any value from the middle because we were able to do it in big O of 1 time constant time. But that is not the case with the heap. So fetching the middle value, it is actually going to take big O of n divided by 2 time because we are doing it sequentially one by one to reach to the middle point. So in that case, since it is taking that much time, can we do some improvements to actually find the median quicker? So now we know that what is the issue with the typical ordered list. Basically inside the ordered list, despite having all the values properly set up using the heap, it will still take us time to reach to the middle pointer, and we want to basically make this process much faster. So how do we do that? Well, one simple conclusion is that breaking this heap into 2 portions. And how do we break this heap into 2 portions is that first we are going to have a max heap. Now what does a max heap means? Max heap is going to be this portion of the given existing list. And if we notice one property in this portion is that every single element at the end of this heap is always going to be the maximum value compared to all of its peers. And this is the only value we care. Same way we would have another partition being made inside our heap, and that is going to be this remaining portion. Now inside this remaining portion, we can actually call this min heap. And why we are calling it min heap? Because the only value that is of concern to us is this middle pointer. We don't care about all of these values. We only care about this value because this is going to be the minimum value compared to all of its peers. And if, for an example, if the current heap size, or if let's say that max heap and min heap, we will try to make them exact equal in terms of the number of elements that are currently present. So let's say that in our current data stream, if the values are even, basically in that case, max heap and min heap, they are going to have even values. And in our data stream, if the values are odd, then in our case, our max heap is going to have one more value compared to our min heap, and that's it. So if the values are even, or if min heap and max heap are same in the size, then the median value is going to be the combination of, or the average of, this max and min heap. And if it is odd, basically we simply need to return this max heap value or the max element. Confused? Don't be. Let me show it to you with an example. Suppose this is our current current data stream. What would be the ordered list? First, let's just try to understand. So median in this case, again, that is quite easy to find. The median is going to be this value number 3, that is the middle value. And why we came up with this value number 3? Because once again, this is the total number of elements are in the odd number, so that is why it is easy to find the median. Now let's see that how would my approach work. So first, let me quickly create a max heap and a min heap. So I'm just first giving you the end result, that how they are going to look like, and then we will go step by step on how to implement that. Okay, so end result is going to be that this max heap is going to have all the values that are greater than the very first element inside the max heap. So max heap is going to look something like this: 3, 2 and 1. Actually it's going to be 1 2 3, but I'm giving you more general idea so that visually it is more interesting, that the very first element is the element that we are looking for. So in this case, this is going to be that. And if we see it with the original list, basically we are taking care of these first 3 values. Same goes with the min heap. What are going to be the values? So the values are going to be simply 4 and 5. Why? Because the very first element is going to be the minimum value compared to all the other values. Now again, going back to our equation of the values being equal or one value being higher than the other. So in this case, currently if we see the number of values in our, okay, this mh is not the best abbreviation, in our max heap. Okay, max heap and min heap. So currently in our max heap, the number of elements are 3. In our min heap, the number of elements are 2. Because max heap has one greater element, the whatever the value of max heap is, or the whatever the value of the very first character in the max heap is going to be our median. And in this case, if we were to ask the find the median, we can simply return the answer as 3. Now let's see that how step by step we are going to maintain this property. So first we have our max heap, and then we also have our min heap. Now the property inside the max heap is that the very first value has to be the biggest value compared to all the other values, and the min heap is that the very first value is going to be the smallest value. And also there are one more property, that every single value inside the max heap is always going to be less than or equal to the min heap, nothing more than that. So first we are going to enter the value inside the max heap, and that is this very first value, 52. So first we add 52 over here. Currently min heap does not have anything, we took care of this value. Now the second value is value number 2. First we are going to check the size difference between max heap and min heap. And what the size difference is going to tell us is that whether the value should be added to max heap or min heap. So if we were to add this value number 2 to max heap, then the size difference between max heap and min heap is going to be value 2. So because this is greater than 1, we cannot have them, which means we will have to push one value to the min heap. But the question is which value, and that is the interesting part. So we know the property that every single value in the min heap has to be greater than max heap because of this one. So if we enter value number 2 in the min heap, will it make sense? No, absolutely not. Which means first we will have to push the maximum value that is currently present inside our max heap to the min heap. So the first we are going to have value number 52 being pushed over here, and then we are going to have this value number 2 being pushed to our max heap. I hope this makes sense. If not, try to rewatch the video for this portion, and you will understand what I exactly said. So now we already took care of value number 2 as well. And also remember, because we have both the values at the same time, if we want to find the median, it becomes quite easy. We can do it in just constant time at any given moment. Because let's say I tell you that after these two values there is a find median command. You can do it quite easily. You can just say that okay, 52 plus 2, 54, 54 divided by 2, I think it's going to be 27, and 27 is the answer. You can find it quite obviously. So that is why this approach is very fast. Now again, going back to our example, now this value number 3 we need to push in. Currently both of the min heap and max heap, the sizes are same, which means the value has to be entered into the max heap, because max heap can have one more value than the min heap. So 3 we know we have to push it into the max heap. Now what is the property of the max heap? That very first element in the max heap has to be the greatest element or the biggest element compared to all the other values. So in this case, because 2 is the small element, we are going to adjust our max heap. So first element is going to be 3 and second element is going to be 2. Now we took care of this value number 3 as well. Now we have this value number 5 to take care of. Again, 5 has to be added to the min heap. So if should we add 5 directly to the min heap, or should we add it to the max heap? We are going to check the very first or the biggest element inside the max heap. The biggest element of the max heap is lesser than the value of that we are trying to enter, which means 5 can easily enter our min heap. So since we are entering 5 into the min heap, we also want to maintain a property inside the min heap that the very first element inside the min heap is always going to be smaller, which means 52 we will have to move on the side and value number 5 we will have to put together. Because up until this point, even if you see that what are the elements, so the original elements were 52, 2, 3 and 5. If you just want to put them in a single ordered list, the value is going to look like 2, 3, 5 and 52. And we are only concerned with these two values 3 and 5, and which we are able to make sure or use using this min heap and max heap. So that's why we are going to get rid of all of this. This was just for explanation purposes, but you get the idea that what we are trying to do. Now again, once again, we have the value number 11 that we are trying to enter. So for this value number 11, it has to go to the max heap. What is the property of the max heap? That the very first value has to be the biggest value. So currently the value is 3. So because 3 is smaller, so 11 will go over here in the middle, in the very first value. So we are going to get rid of these two, and the value is going to be 11, 3 and 2. And currently what is going to be the median value? The median value is going to be value number 11, the biggest value of our max heap. But question is, can 11 stay there? Of course not. Why not? Because every single element inside the max heap has to be smaller than every single element in the min heap. And currently we have value number 5 that is actually smaller, that is residing in the min heap. So that should not happen. So once again, we will have to first, before adding 11 over here, first we will have to add value number 5 over here. And then since the size differences between max heap and min heap is greater than 1, so 11 would rather going there, it would enter over here. And in this case, the values are going to look like that 11 and 52. Okay, now we have the very final element 7 that we need to enter. So where should 7 go? Again, this already has one element greater, so we know for sure that 7 has to go to min heap. But 7, we are going to compare 7 with the very first element. So 7 is greater than 5, which means 7 can easily go into our min heap. And since 7 is the smallest element, we will have to make adjustments before we enter 7 over here. So the values are going to be 7, 11 and 52. So in the end, we are going to have our two min heap and max heap. So max heap is going to look like 5, 3 and 2. And the min heap is going to look like 7, 11 and 52. And now if we are being asked to calculate the median, it is quite obvious. We are just going to do addition of 7 plus 5. So our value is going to be 12 divided by 2. And the answer is going to be 6. And this is the beauty of heap. And this is why this problem is a hard problem, but also very popular problem. Let's calculate the time and space complexity. So again, for the time complexity, first we need to find that for the max heap and min heap. So insertion takes log n time, and essentially we are going to be inserting values in the max heap, min heap, sometimes from max heap to min heap and sometimes from min heap to max heap, but in either case we are going to be achieving that in log n time. So essentially we are doing log n 4 times, and then for the one time we also have to enter the value from the data stream to one of the heap. So essentially we are actually doing the log n operation 5 times. So if you want to be very specific, you can mention 5 log n to be the exact time complexity, and plus in order to find the median, this operation is actually constant, so big O, that is being done in big O of 1 time. So this is a very good time complexity. Now let's calculate the space complexity. So space complexity is basically going to be big O of n, where n is the number of values that are currently present inside the incoming data stream. So here is the coding solution. First of all, we are creating our class called median finder, where we have our two priority set. First one is a priority queue named low, that is our max heap, and second one is our min heap. Now we need to create a method to add number. Basically, to add number, we are first of all adding it to the max heap. Then we are balancing the both the heaps, and then we are checking that if they both are maintaining the proper sizes or not. If not, we would pop the element and move it to the other heap. And in the end, it becomes quite easy to find the median, and that is essentially you just check the size. If the sizes are equal, then you do the average of both the lowest and the highest value and divide it by 2. Otherwise, you take the value from the max heap and return it as the answer. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently, and I would be posting this solution in my GitHub. So